Start. Now we can start this thing. Okay, so I cleaned up the playlist. I had the wrong title in there, so day 3 was there. It just had the wrong title, so that's published. You're gonna have to wait for day, which is probably good because now you just saw that day 3 showed up, even though I actually did it a week ago. But I didn't fix it till today, which is day 4, and I can't upload this video because YouTube gave me a strike for watching American Gods in an IRL video while I was like doing laundry. So I am not, for the most part, I will not be live streaming to YouTube any longer. I invite you to join my wonderful Twitch community if you want to watch me live stream. On occasion, I will stream to YouTube and Facebook. I mean, it just really depends. But for the most part, I'm going to stay with Twitch. Twitch gets me. It gets streamers in general. It doesn't freak out when you play music or you walk. I've had a 6-hour video demonetized because I walked into a shopping store with music for like, maybe 20, 30 minutes. And the entire video was taken down and blocked worldwide because of it. I really don't like YouTube. There, I'm done. All right, so recording is on. We did day 3. So day 3, we set up our technical lab. So let's go over what you should have before you start this day. You should have a computer with a terminal. That means you should have a Mac or a Windows box or optionally a Linux box. I didn't talk about it, but if you set up your own Linux box, that's cool. And then we're going to have a command line. We're going to have a terminal command line. Um, you should have experimented with VS Code, but we will not be using VS Code at all going forward. I did want to make sure that you had access to VS Code and that you understood it because it is a critical tool. And many of you will find using VS Code to be much easier if you just want to do the coding part of the beginner boost and you don't care about learning the terminal, which is going to be the primary focus for today. Today's focus is going to be learning the terminal enough to be able to use the terminal in a productive way, to edit files, to move around, to navigate files, and with the goal of creating our first website, which is going to be our first project that we're going to do. We're going to make a very simple website using the command line after we learn the basics of how to edit files and how to move files around and a little bit about file permissions and all of that stuff. So that is really the main focus for today. Today's only going to be a 2-hour video. We're not going to go deep into all of those things. I'm trying to decide if going deep into those things is going to be in the boost or if just telling you about it and letting you go learn about it with your AI is the way to go. That's a good opportunity for me to remind you, if you don't have ChatGPT to help you learn or something similar, I strongly recommend ChatGPT above all the others for personal learning, specifically for personal learning. For writing code, Claude is the best. And I've done videos on this, Claude versus Chloe. You can go watch that video if you want. But if for all of you watching this video, if you don't have an AI as your personal helper, instructor, teacher, and organizer, stop right now and go do whatever it takes to get yourself ChatGPT or something similar. But I cannot overemphasize how powerful and important ChatGPT is for learning. It has been overwhelming. And that's another good segue into a little bit of a review of the calendar schedule. So the calendar's been very fluid recently. This is the calendar currently. So you can see here, we're only going to do 2 hours of beginner boost on Saturday, with the goal being answering questions and showing you what you should have done last week and what you should be doing in the next week, but not to necessarily show you how to do all of those things. It's more important that you know what to do so that then you can go on. And that is why the AI is so important. Rather than having me tell you, I don't know, how to edit files or change directories, you should be getting in the habit of asking your AI to do that. And that, by the way, is what I can't say the names, but 2 of the private mentoring slots that have been taken, these people are doing this already with me. In fact, one of them, I told them this, and I came back, and they had created an entire learning plan with dates and estimated things and recommendations for companies to work for, recommendations for the technology that they needed to learn. This person had actually given the AI the idea behind a skill stack, which I covered in another video, and the AI helped them create the skill stack and choose relevance and scores and everything. And this was all done in ChatGPT. And when I came back, I was blown away. I was blown away, even beyond any expectation I ever had. I was like, I could not believe the level of detail and quality in this person's personal learning plan, down to which job fairs they should attend to get a job in the local area. They found 2 job fairs in the area that were free to attend to help them get a job in their state. And this all came from AI. So if you are not leveraging ChatGPT, I'm sorry, I'm getting excited. I'm getting excited. I'm going to calm down now. But let me just restate this. If you are not leveraging ChatGPT and AI for your learning, forget about anything in tech. Anything. And quite honestly, forget about any job, because almost every job, short of construction, is going to demand that you are using AI to help you write your emails better, to help you soften the blow when you have to communicate with your manager about something you're pissed off about, which my manager may have recommended to me. Because I'm pretty abrupt the way I communicate, but you run it through an AI and it helps you out. Does it, I don't care what you think about having it make you irrelevant and all this stuff. I don't care about any of that. This is the new reality. And if you don't accept this new reality, then I don't know, go be a park ranger until your job gets cut. Okay. Eh, which is that's me. I actually wanted to be a park ranger. I would be unemployed. Basic use of a developer tool. No, we're not doing that. All right. So anyway, I just want to put it out there. ChatGPT or something like it should be your primary You should actually have a person as your primary mentor if you can find one who's willing to help you and not scrambling to make ends meet with the economy the way it is right now. But if you can actually find someone to spend a little bit of time with you, then that's your number one source. The number two source is ChatGPT or something like it. All right, I spent a lot of time on that. Let's get into it. Let's talk about what the terminal is and what it isn't. Um, and we're gonna create our own first website today. Okay, so let's actually I'm gonna briefly give you a summary of what the terminal is. We already did it last week, but I'm gonna do it again. So, Telescale, get out of my way. First of all, you need to start up a terminal. Now, if you're on a Windows machine, it's Windows key. If you push the Windows key and type either bash or terminal, it'll pop up your terminal and you'll be able to go to the terminal and start working. And I am actually, well, I'll do it later. I forgot to set up my Rust desk in order to run the Windows at the same time. But the goal is to get a terminal open. If you forgot how to do that and you want to use VS Code, you can open up VS Code, and we talked about how to open the terminal there. We already covered this. And if you're on a Mac, then it's control space, command space, and then terminal. And that will open up the built-in terminal of the system. This is almost always when someone's going to say, well, what about Ghosty and all this stuff? We already talked about that. We are using the basic built-in terminals on Windows and Mac for the boost. If you want to use any of those other things, be my guest and exchange knowledge and ideas and opinions in the forum, in our GitHub forum on the GitHub boost, which is, github.com/rwxrob/boost. Make sure you're over there in the discussion forum so you can ask these questions about what's your favorite terminal, blah, blah, blah. But for today, and for purposes of getting a job, you just need to use the built-in terminal. Okay, that means you use the one that comes in your Mac. Mine has been customized in color, which I'm not going to teach you how to do. It's super easy to go just to the settings and figure it out. And that's what you should do. You should get it customized the way you want it to. Some of the customization with regard to the command prompt, as you see, we will cover, just not today. So you should have a terminal open. It might be black and white, which whatever your colors are. You might want to change the fonts to get it to where you can see it nicely. And I'm actually going to expand the space of this so it's a little bit bigger. All right, now I am now going to switch over to my preferred terminal because the colors are better in my preferred terminal. But I wanted to show you how to pull up the default terminal. So my preferred terminal is WesTerm. I strongly, strongly recommend that you consider WesTerm, mostly because it's so much faster. And it's written in Rust. It's a great Rust app, and it can be configured to run on Windows or Mac using the same configuration file. And that is really important when you're working in the terminal. So we're going to go ahead and clear the screen. And my prompt again has got a lot of interesting things in it. Just to let you know, let's talk about what's in the command line prompt. For most prompts, it really depends on the application, on the OS, how you set things up. But usually, always it'll have the username here. That's my username. And then almost always it'll have the name of the host. I have a funny story about that I'll share in a second. And then it will have any number of interesting things that you may have configured. But usually, the minimum everybody's got is this: they have the username and the host, right? I personally am just going to say it now. I think you at least need to know what directory you're in and what Git branch you're on. And as a technologist, as a professional, not knowing what Git branch you're adding and editing is super bad because you'll end up committing to main or to the wrong branch and you have to go all the way back and forth. So, in my opinion, and we'll revisit this later when we do command line configuration and stuff. In my opinion, the three, the four essentials are what's my user, what's my host, what's my current directory, and what's my Git branch. People put the weather, I almost swore. People put the weather and they put like, I don't know, whether how many days to their birthday. I mean, they put all kinds of random stuff in the prompt that they don't need. Um, and there's been scientific studies that show the more minimal the prompt, the better, because you want the prompt to fade in the background so you can focus on the actual content in the front. But I do want to tell you my story about that causing a problem. So very early in my career, this was in 2000. Let's see, I'd been at IBM since 2000. Yeah, it was just in the year 2000. So right after Y2K, which I did for Nike, and uh, I had the bubble burst, and I had to switch from developer, being a software developer, to an operations person. So I was working in Linux as a system administrator, Linux and Unix, Solaris Unix, as a system administrator for the first time. And this wonderful manager of mine hired me and took a chance on me because I'd never worked as a system admin before, but I had an entire lab of Linux machines that I'd been managing for some time. And I got really into Solaris and Sun when Unix, when I was at the internet service provider where I did all the coding. And so I went home for the night. I put Linux on my laptop, which, everybody wants me to teach them how to do. Flash a USB drive, deal with your BIOS, proceed to install on your laptop. That's the process. I'm not going to cover it. Um, and so I had this laptop. I brought this Linux laptop in, and interesting fact, none of the people on my team who were professional system administrators had ever used Linux. They had all only used Unix Solaris Unix, and AIX. They'd never even seen a Linux machine. In fact, I was the noob on the team and who had never done sysadmin before officially, and I ended up teaching. I got a thanks award for it. I ended up teaching my team how to use Linux and how to install Linux on the laptop. So Linux is a great way to learn, and installing on a laptop is definitely valuable. Just not for everybody. That's why it's not in the boost. But here's the main part of the story. I did not have or did not pay attention to the host name in my prompt. And I had been placed in control of it's really crazy, but I had been given control of the mail server because I was the only one who knew how to do mail routing, even though we had lots of veterans in the group, because I was running my own mail server at home. Another reason to have another home lab, I've talked about that before. But this particular day, I was tired. It was late in the afternoon. I wanted to go home. It was the end of the day. And so I typed one command, and don't you dare type this command right now. Shutdown -H now. This is an old school version of a multi-user system command that used to send a wall request that would go out to everybody and tell them, hey, get ready, the system's coming down. So 16,000 users at the university would know to take a break. Um, and I ran that command without looking at where I was, and I took the mail server down because I was logged in on the terminal to the mail server. And I forgot, and I was like, oh crap. And I lost my terminal prompt, and my laptop didn't go off. And I was like, why is my laptop not restarting or not going off? And then I looked at the prompt and I was like, I was still at the terminal prompt. And what had happened was it had disconnected me. It had disconnected me. In fact, I can show you, but it had disconnected me from my server, from the server I was on, and it had dumped me into my laptop's terminal. And so I was still in the laptop terminal. And I went, oh crap. And I had to go to my manager, and it, for whatever reason, the system that I had tried to shut down stopped before going all the way down. There's different init levels. And the level that it stopped at meant that I didn't have access to it, but it was still sending mail, thank God. And so we called up, I think it was Boulder, Colorado, and the operator went in and flipped a switch on it and brought it back up into full network status. And we didn't lose any mail and nothing went wrong. And I went, you're going to fire me, right? And my manager said, no, why would I fire you? You're going to do that again? I went, no. And he's like, well, if I hire another guy, they'll fire that. That person will do it because now you know not to do it. I'm like, thank you. And so that was the first story of being a great manager, being terrified and not paying attention to what system you're on. So, so, and in this world, you'll be logged into a Kubernetes box. You'll be hacked into somebody's machine. You have to be really, really careful where you are. So take that story with you and just remember to know where you are. I spent a lot of time on that because I really, really don't want you to make this mistake. This mistake can cost a company thousands of dollars, if not more, if you take the wrong system down because you're just not paying attention. You shouldn't be terrified of the job, but when you get on the terminal, there's a lot of power, and with great power comes a lot of paranoia and responsibility. Okay, so anyway, so there you go. That's the prompt. So this is your first time. I'm assuming this is the first time you've ever seen a command line prompt. So there's one other thing to talk about, and that is this little guy here. You see how that's a dollar? So what that is, that usually the dollar sign means that you're a regular user. You might have admin permissions on the machine, but right now you're just using your regular permissions, and nobody should be scared. This is when you should be scared. Um, Oopsie. Okay, now see this? This is another example of a prompt. So this is the default prompt for the root user of my, in this case, my Mac. Right now, I can seriously screw up my computer because I have root access. You know, Q root got root memes, right? Got root Q sudo su make me a sandwich. Can we show you that? I'll show you that one really quick. I'll show you sudo make me a sandwich. This you can get t-shirts with this. So make me a sandwich, make it yourself. Sudo make me a sandwich. Okay. It's kind of an in the know joke, right? So sudo stands for super user do. That means do the command as a super user. And in this case, I did SU, which means switch to the super user, and the dash means make it a login shell. So what I basically did there is I escalated, I'm going to use hacker terms here, I escalated my privileges explicitly to root on the machine. That means I'm no longer, as far as the computer's concerned, I'm not Rob anymore, I'm root. And you can do whatever you want on the system there. There's a couple of things to note here. One of them is this hashtag. The hashtag means that you're root. And if you're on a Kali Linux system or any other system, I'm actually going to show you a couple other systems just by default so you can kind of look around. But it tells you the user here. This is your directory. So tilde means home. in on a system like this, you can see that I am not in my home. I am in the user's home. Okay, and we're gonna learn the cd command and a couple other commands as we go. So, and here's the user, and here's the colon, and this has at instead. So you're gonna see a bunch of different variations on the prompt. And actually, one of the reasons I want to do this is I wanted to show you podman run it. Let's type Kali. Is it Kali Linux Kali? I think it is. I think it's Kali Linux Kali. Does anybody remember what the name of the container is? I can't remember which one it is. I mean, my ChatGPT probably knows. What is the image for Kali Linux? I think it's Kali Kali. I don't have it on the system. I'm going to pull it straight down, so that's why I don't know it. Uh, this is one of the reasons you installed Podman. Kali Linux Kali rolling. Actually, okay, they changed it. Kali Linux Kali. Is it a dash? No, rolling. So this is the current one. All right, so what am I doing right now? I am using Podman, which you should have been. So I wanted to show you this because this is color. So uh, this is a prompt from a Kali Linux system, which is the Kali Linux. We'll talk about Linux distributions later, but Kali Linux is a hacker security distribution. It's designed for it comes from offensive security where you can get certified in Kali Linux and get a job for the government or a bank or something, which is still a job even though AI is kind of messing with it. And this is how you run Linux inside a container, which is very common using Podman, which is a container engine compatible with Docker that replaces Docker in every responsible, important way. I'm just going to put it out there again. Don't use Docker. Don't use it. Learn Podman. Businesses do not use Docker anymore. If they're still using Docker, they haven't got the memo that Docker is irrelevant, broken, and a horrible company. And there are many reasons for that I'm not going to get into right now. So make sure you learn Podman, and because that is the new normal default that comes from Red Hat, which companies overwhelmingly trust more than any other distro out there. Second to that is probably Ubuntu, and SUSE in close third. This is not me telling you my favorite distros. This is me telling the distros you are most likely to encounter and have to be effective on as a tech professional in the tech world. And Kali Linux is the one for security. It's not meant to be a server distro. It's meant to be a tools distro. And you'll notice I didn't mention Arch, and we're not going to get into the distro thing right now. I just want to show you the difference between the command lines. So you can see that when you log into Kali Linux, it dumps you into root. So the thing to take away from this is when you are running inside of a container, almost always, because you're in this self-contained container that's supposed to be really safe and everything in the container is root. So that for old people like me, we really gristle on that. We don't like it because we grew up in a multi-user Unix environment where running as anything as root was considered super dangerous because if you make any mistakes as root, people die or whatever. So you don't use root. You use sudo as a single command. This is still mostly about showing you the prompt, but I also want to show you the difference between root and user usage. So when you're inside a container, being root is not something to worry about as much. Why? Because as soon as I leave the container, it's going to get thrown away. It's called being ephemeral, which means it just doesn't matter. It gets thrown away. You do your things with it, and then you throw it away. It's like spinning up a Unix machine, a Linux machine, sort of doing your work, and then throwing the whole thing away, and then bringing another one up, and then throwing that away. That is the modern way to do work in the enterprise using containers. We will cover containers more deeply later, but that's just to give you an overview of why it looks like the way it is right now. Root equals admin access. Yes. I mean, you can have admin access, but until you invoke root, you can't do the thing as admin. It's slightly different on Windows because there's Windows permissions and then there's the Linux permissions, the WSL permissions, and that's two separate systems on Windows. This is confusing for Windows people because you literally have two operating systems running next to each other when you're using WSL2. So if you have typed bash from the terminal command line, you're not using Windows, you're using Linux. Okay. So, and then you can use your containers and all that the other stuff. So, but just a note here. So this is the randomly generated name of the host. If you actually wanted a better name here, I think you can, I think it's -H. You guys have anybody remember? I think it's -H. Yeah. If you do -H, you can give your container a name and then start it up again. And you can actually give your containers podman ls or ps will show you all of your containers. There are none running right now, but you can do is it -a what am I doing, Robert? I don't use this command a lot. There we go. So here's all the containers that I've been running. They're these by here are the names that are given to them automatically. If you'd rather not type in that crazy number over here, or you can actually give them a name. We're not going to get into that until we get into the container thing, but I just wanted to give you that as kind of a summary. If you want to reconnect to the same container, you can also do that. We are going to do containers because the beginner boost, the repo is a container. You can actually run that as a container. All right, so we're gonna go ahead and clear the screen. Clears the screen. Every time I do a command that you don't know, you should be taking note of it, either on a piece of paper or on your notes on GitHub or in Obsidian. However you want to take your notes, you should be writing that command down as we go. There is a definitive list of every single command that you should know that I have been building over time. That is actually in the boost, if I remember right. It's it's been kind of an ongoing list because it's got so many things on it. Um, Clear, did I say clear? Can you smash program interfaces like Wireshark from the container? It depends on that. You can run certain applications from inside a container, but a container is not an actual system. It's an application, and and it's in this case, it's so it looks like Linux. It's really not. It could have all the tools in it. BusyBox, for example, is a single binary. Um, I'm trying to find, yeah, mandatory commands. So I do have a list of mandatory commands that we have been working on. I noticed I don't have clear in here. So if you are a veteran and you're watching this and you want to help by doing a PR against this, that would be really helpful. And I'm going to sort everything. There we go. So do I have two clears in there now? I do. I just hadn't sorted it before. I'm editing this file using VI, and I'm sending all the content to a command and replacing it with its output. We're going to learn all of that cool stuff eventually, but this is where the list is. So it's in docs/mandatory commands if you want to go look at that. Um, uh, Containers are used to modify the application. No. Um, yeah, a container, strictly speaking, a container is an application running in a shrewded contained Linux container space. So it doesn't have access to the system unless you grant it while it's running in the container. But it's we're kind of getting down the container rabbit hole a little bit too much here. I was just talking about prompts. So let's go. I want to show you another couple of prompts before we leave the prompting thing. So let's run another thing. Let's do I think we did BusyBox before. Okay, so this is a BusyBox. Uh, what is container versus VM? We're not going to talk about container versus VM right now. Virtual machine. So you see here we have a BusyBox system. Now, this is very deceiving. So if I type clear here, I am now running inside of a BusyBox system. And as I said, a BusyBox is a variation of Linux, ls, you can list things, but look at the prompt. Look at the prompt on BusyBox. A shrouded environment just means that you're not able to go out and do anything to the system it's running on. That's what it means. Yeah. And we are not going to explain multi-call binary right now. No, God, no. Are you kidding me? Um, a multi-call binary, actually, I was asking about, is a single binary that operates differently depending on what its name is. And when I say binary, I'm talking about a program that runs does different things depending on what its name is. And it can have lots of different names, even though it's all the same binary. When that gets into links and stuff, which I don't want to do. We're talking about prompts right now on the terminal. So here we go. This is a single, you see it just gets a hashtag that shows you have root and it tells you what directory you're in. If I cd into bin, we're going to go through bin and cd and ls and all that in just a second. So now I'm in the bin directory and I can type ls and I can see all the files here. If I type ls-l, it'll show that all the files are the same size. And that might seem interesting. They're also this is the number of links to that file. That's 406 links pointing to the same underlying binary, and that's how you can tell it's the same because they're all the same name, same date, and everything. This is a multi-call binary. Every one of these entries in the directory, they're called inodes, is pointing to the same binary code in a file inside the container. And that means they're all the same. The 406 is the number of hard links that are pointing to the same underlying thing. You can delete any one of these and it will not affect the other ones. It just deletes the link reference, the inode that points to that space on disk, that memory on the disk drive. So that's what that is. Now, if you um, I guess we're kind of talking about LS at the same time. If you want to, let's go try a different operating system, Linux operating system called Alpine. Very popular, very lightweight, and for all the same reasons. Alpine is built off of BusyBox. So BusyBox and Alpine are very close to being the same, except for Alpine has a different package manager. That's how you install software. And we won't talk about that at all, but as you can see, it has the same prompt and it's telling you what platform you're on. Again, it's got a little more than BusyBox, right? So this is a Linux distribution. It's got more on it. But if we do the same and we go into bin, cd into bin, and we type ls, you can see it's got green files in there. What's up with that? Okay, these are symbolic links, and the L over here means symbolic. It means it's a link. And hard links, as you can see, these are different. These are not multiple inode listings. These are multiple files. And an inode is a file, but a file is a specific type of thing. So if I delete this file, something actually gets removed. And it's not just a removal of a pointing to the same, that's what a hard link is. So in Linux, this is super important you understand this. In Linux, there are actual files, and then there are links to those files, and there are both hard links, which are that don't have the arrows, and there are symbolic links. And without getting into too much detail, the primary difference between the two is that you can modify and mess with a symbolic link, change it to point to something else. Symbolic links can actually point across file systems, which is a concept you haven't learned about yet, but a file system is there's like multiple ways to store things. Let's say you had two hard drives on your computer. Um, each one would be a separate file system. I'm simplifying, but um, and in order to symbolically link from the one file system to a file on the other hard drive, you would must use a symbolic link to do that. You can't do that with a hard link. Okay, so um, and those there are other reasons to look at this, but that so in general, you're going to want to use symbolic links. Um, Another reason, it's just so much easier to see what it's linking to. A hard link is impossible to know what it's linking to. I think there are commands to look it up, but it's very hard. It's much different because it's just an item. But symbolic link is always showing you exactly what it's pointing to. Um, so in this case, you'll see that it is using the BusyBox binary, as was the BusyBox that we just saw. The difference is that this multi-cult binary uses a symbolic link to point to it. But the BusyBox program inside knows that it's being called through a symbolic link named sleep, and therefore runs the sleep code inside of it, even though all of them are the same binary. That is a multi-call binary. There are a lot of veterans in the industry who still don't know what that is. I promise you, there are people who still can't tell you what a multi-call binary is. And I have made so you can create a symlink backwards my entire career. Yeah, I do too. We haven't talked about actually adding links do something else. Uh, but these are all the same thing. As a kind of a side note, if you want to, I created the Bonsai project for making commands, and one of the primary things I did there was to be able to make a single monolith multi-call binary that then you could put all of your favorite commands in, and you could create a container that's much like Alpine of your own creation, and you can put your own hacks and your own file resources in there so it all travels in a nice happy binary. um, that's more for the other people out there, but hackers love it because they can put everything into a single binary and put that binary into a container, and they can run that container anywhere with all of their favorite tools in it. So if you want to get into making your own multi-call binaries, this is extremely advanced stuff, but keep Bonsai in mind, and Bonsai Bonzai, and go have a look. But we were talking about prompting, um, so that's all it really is. Yeah, that's really all it is. Absolutely, Electioner. Yep. And so then we have the hashtag, and we have bin, but you don't know what user you are, right? And there are a bunch of commands to know what user you are and all that, but right now you just use the terminal for the first time, and I've already blown you away by talking about multi-call binary because somebody asked about it. So stay with me. I promise, if you need to pause the video or fast forward, go ahead. So here we are back on my computer. Um, the only other one I wanted to show you was probably Fedora. Fedora is a Red Hat Linux distribution. Let's see what it looks like. So this is copying down the container image, and here we go. So here's another prompt. You see we're on root. You see we're on the random thing. This is very much a Red Hat thing. Red Hat puts everything in brackets and then puts what directory you're on right here, but we're root. Everything else is the same. So, by the way, every one of these operating systems uh, does colors differently. So, like, for example, this one right here, you'll see that this is because it has set UID permissions, which you'd want to know about if you're a hacker. It's one of the ways you can break into a system. In fact, I saw B7 doing this today. Um, so, you're going to learn a lot more about all of this. We're just talking about prompts right now. So we have looked at the interactive prompts from, WSL2, which you've already looked at. We did that last week. Uh, from the base terminal on Mac, which is Bash. You can actually execute a different shell if you want. You can run exec bin Z shell if you're on a Mac, and run a different shell. So Z shell is a different shell. We're going to talk about shell next. That's where I'm going with this. And you can see that the prompt is very similar, but it's got a percent, right? For some reason, Z Shell has chosen to use a percent instead of a dollar sign. Same thing, it's just a standard user, right? If I do the sudo dash, let's see what it looks like in Z Shell. Uh, let's see what this looks like. And okay, so again, really no distinction. I am now running, I wonder what my shell is. Oh, I'm bash. So that's interesting. Yeah, it looks like on root, the root default shell is yeah. Anyway, let's go back to where we were. Okay, this is kind of weird because I am running Z shell even though I'm in a shell on a Mac, right? So, and there's my other window. There's my Claude. So let's open this up. All right, here we go again. So, just to review, we've looked at multiple shell prompts from different systems so that you know you're comfortable on the command line. Okay. Now we're going to start talking about, I've already talked to you about that the terminal is just an interface. So here's some terms to write down. TUI, Terminal User Interface. A terminal user interface is simply that. It is a user interface to a computer through the terminal. That's what this is. It's not to be confused with, and I'm going to put these in my notes. Um, let's go see if I can find it here. So, okay, on dot files, get your personal page, set up tech lab. Okay, let's actually put one here. Whoops. And let's do this. Okay, understanding the terminal. Okay, so I'm going to put some terms here. So terminal user interface. What is a terminal user interface? TUI. What is a command line interface? And what is a graphical user interface? Anybody have any others? Anybody have any others? For a long time, I had something called a conversational user interface. And I'm not going to list it here, but that's actually where things are going with the assistants. There are a lot of assistants that are coming up, and they have different names, but I call it a conversational user interface. Um, CUI, that's my name for it. I'm two type there. This is becoming a thing. Is like Claude, for example, you can hold space down and just talk to it the whole time. You don't have to do any coding. There is a terminal involved, but it could have been anything that takes in the content, the reason this probably does not going to have its own category is because usually a conversational user interface is being implemented in a terminal or a graphic user interface. So let's talk about all four of those terms, three of the main ones. So a graphic user interface is pretty obvious. That's when you've got, you know, you got widgets, you got clickable things. People love to fight about the best graphical user interface on Linux. Don't get sucked into those time-wasting conversations. If you say you're a Linux user and they ask you what your favorite desktop manager is, just walk away because you have other things to do. If they tell you all about how they think i3 is the best way to manage your Windows, just walk away and go do something that matters. Nobody cares. Or if you want to be snide about it, you can say my user interface is Tmux. And I'm like, what's that? Okay, and we're going to talk about why that is. Because the interface that we are going to use exclusively for the beginner boost, now that I introduced you to VS Code and a little bit of, web browsing in Chrome, which you can't get away from, both of which are graphic user interfaces, um, we're going to be living in the terminal. We're going to be learning terminal velocity. That means learning how to do things in the terminal quickly. Um, and we're going to talk about the relevance of the terminal into 2026 with, AI and everything that's out there today. And there are many, many people who are going to take exception to you using the terminal. I regularly have to defend not just me, but other young people who have decided to be more efficient than other people who are completely tied to VS Code. You make your own decisions. If you want that to be you, I'm not going to judge you, but I'm going to look down on you for sure. If you're just using VS Code and you don't know how to rename files, I'm using Obsidian right now, and people are already looking down on me because, like, why are you not editing all that stuff from the command line? Because it's less efficient. You do whatever's efficient for you. All right, so here we go. Why was it not Z shell for root when you do Echo shell? Because the default shell for Mac is Bash. Sounds like you're judging me. I am judging you. Who am I kidding? If you use VS Code and you're judgy, you best believe I'm making fun of you. I've had people like laugh at me for using Vim. I've had that happen at work, and I'm like, okay, hold my beer. The default shell for root is not Z shell. The default shell for users on Macs is Z shell, but not root. That's kind of interesting, right? That's what it appears to be. I don't know why. That is why it appears to be. Uh, you think Terminal is making a comeback thanks to CLI AI agents? Yes, and I was going to talk about that later, but let's go ahead and talk about it now since Fisher brought it up. Um, this, as you can see here, I'm gonna demonstrate something to you really quick. So, right now I have this is me using Claude, which is the leading tool, agentic tool for doing development of all kinds, operations as well as hacking. And what I want to demonstrate to you is the use of a TUI that is integrated with agents. So an interesting phenomenon has been happening. It's been popping up in February of 2026 in particular, because the agentic AIs, the ones that operate on the current environment, that means they have access to everything you have access to, which is scary and wonderful at the same time, all use the terminal. In fact, Claude Code is the number one, and that's what this is. And then you have GitHub Command Line Copilot extension, also competing with Claude, almost a verbatim copy of the UI. And they are both terminal UIs. Now, something that the Claude UI has added is a conversational user interface, and I want to show this to you. So I can actually do this. And again, the point of all of this is to illustrate why the terminal is important in 2026 and how dumb people that are on Linus Does Tech, making fun of old people who use the terminal. I was there for that actually, are really clueless because that's how all work is getting done today. I'm going to go ahead and do this, and I'm going to go ahead and do a brew upgrade. You don't know how to do this yet, but this is how you install and upgrade software on a Mac. Actually, I think you did learn brew before. So we're going to upgrade Claude on here. Cast. Oops, I always have to do Claude code. I always forget that. So we're going to upgrade Claude. Again, the point here is I want to show you, as Fisher said, how important the terminal is for coding with AI. And I don't have to tell you, coding with AI is the only way to code in 2026. If you're doing anything other than that, you'll either be fired or you'll be left in the dust. And I am not exaggerating. I am not exaggerating. This is how it is. So, just get used to it. So I'm going to rerun Claude now that it's been upgraded to do its thing. So I can sure you want to run that because I can do all kinds of things. And then I can say, now because voice has been enabled, I can actually hold the space bar down. And if you don't know about this, it's slash voice to enable it. And that toggles voice mode. So that you do voice and it'll add it. Um, and then I can say, what should we say? Let's say it's something I wanted to do actually. I want to say, uh, can you make a plan for watching what's in my chat and responding to commands from certain users? Oops. Can you make a plan? Wait, voice is not working today. It's still working. Hello, check 1 2. It's not working today. Voice is finicky. Sometimes it works, sometimes it doesn't. Let's try again. Hey there, are you there? Hello? 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 It's so quirky. Check 1 2, check. I wonder if it's not connected to my mic somehow. Hello, checking. Well, it's not. It's got a problem right now. Hey, can you take a look at what's going on now? I'm just holding space down and it's not working. I'm gonna try one more time because it's really cool when it works. They must have just added this. The GitHub command line tool doesn't have it. Um, hey, are you there now? It's not working. Hello, check. 1, 2, 3, 4, check. I think the AI, the interface must be bad. Loud and clear. I'm burning tokens for no reason. Can you prepare a plan? I wonder if it's because I'm streaming. Here, let's try this. All right, just pretend I'm not talking to it. All right, prepare a plan for adding a uh, a bot that listens to to all lines from Twitch and responds to certain commands by running a command from a configuration file mapped to the arguments. So you still have to type, unfortunately. It finally did hear me. Yeah, it took a while though. So this is just a really quick demo of what coding looks like in 2026. Um, it's reading my entire GitHub repo. It's analyzing everything in here. It's reading my README MD file. It's particularly paying attention to my agents.md file, which gives my preferences, like I want to do this in Go, or I want to use force-space indent and all of those things, so that it comes back. And it's burning quite a few tokens right now, preparing an entire application, an entire Twitch bot that would listen to your commands that are coming from Twitch and play a clip or do whatever I want to based on a file that has what the message is and what the thing is I want to run. So it's going to write a plan for it. It's not going to make any changes for it yet. It's just going to write this big long plan, and it will take some time because I gave it, that's a pretty big prompt. I'm asking it to do quite a bit. And there are people who regularly will use these kind of tools. Sometimes they'll use multi-agent tools, and they'll start off a thing like this, and they'll go to bed, and they'll wake up, and the whole thing will be done. In fact, there have been three really substantial news articles recently, this last week in the Mail, of people doing this to create replicas of entire software as a service providers that they were paying 300 bucks a month for, and now they're paying nothing because they replaced the entire provider by an application that took them, it cost them about $250 in tokens to generate for them, and then it ran all 700 of their test cases perfectly. This is modern development, and I wanted you to see this really early in this year's beginner boost because in 2026, the agentic AIs have gotten so good that this is the new normal. I coded 2 weeks worth of code in a day the other day, and so here we go. Creates the files, new Twitch bot. You see how this is all text, by the way? This is all in Markdown, which is why Markdown is so important. Update agents with a chatbot.sample, cache Twitch bot token. Okay. It's going to do that. It's going to make a Twitch bot. It's going to add a Twitch bot helper, load commands, get token, IRC, dispatch. Okay, so let me ask some questions. Will will this be using the Twitch command tool? And I because I didn't see if it was going to use that or not. And you can interact with it and give it all the parameters. Only for token management, Twitch token, blah, 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 to cache credentials, the Twitch token P, the actual IRC connection is a WebSocket where the WebSocket directly to the thing. This is so cool because WebSocket is a relatively new tool. It's a command line tool that you can use to talk directly to WebSockets over IRC, which is really freaking cool. Twitch CLI doesn't have a chat listener built in. Okay, good. And you can interact with this is all using a terminal user interface. This is why it's important. If you're having the feeling right now, like, I want that today, go for it. Go for it. You can start playing with this today. You can install Cloud Code. You can install GitHub Copilot. Any of these tools, you can install them today and start playing with them. You know how to use Brew, the package manager. If you're on WSL2, you need to know how to use APT package manager. Um, and I think we have already talked about package management, but it's probably worth going back to that in a bit. So yeah, uh, let's see. Sometimes it'd be completely shocked when it runs amok. It can definitely run amok. Yes. How expensive is Claude? Um, I'm paying 200 a year. You can pay a different pay a different amount for different kinds. Yeah, WebSocket is so cool, isn't it? It's fun because it makes it really fun to write WebSockets applications from the command line. Um, I'm not going to run this, but I actually am going to run this later. This is a project I've been working on because I want to be able to play clips like this
So there.
uh, from the command line and from the Twitch users to be able to play their own clips. So, I mean, the Claude's going to do the whole thing for me. I'm not going to code pretty much any of it. Do I need to be able to read the code? Yes. So, learning the terminal, as you can see, doesn't get you over the need to be able to read code and stuff. So we'll get to that as well eventually. There's a $20 a month plan as well. The highest class subscription is 200 a month. I'm not on the 200 a month subscription. I'm on the $20 a month. So I think I am. I better not be on the 200 a month. I was trying Claude out. I may have signed up for the wrong one. Um, but the people that use Claude at that level, they easily make their money back. They're using Claude in ways that save tens of thousands of dollars. It's insane. So aren't going to need Claude Max, right? So, by the way, you don't need Claude at all unless you're going to go into this kind of thing. You should start with ChatGPT because that's where you're going to ask questions. You can actually use ChatGPT to do development and copy and paste between the two. I did an entire application that way, an entire Twitch overlay, just a vibe coding in ChatGPT and cutting and pasting the code over. It's much harder, but it's also very safe. It's much safer for a beginner. I can't really recommend to beginners that they jump full on into Claude, um, until they learn a little bit more about how powerful the terminal is. You remember that thing I told you about shutting down the server? Well, when you're using an agentic AI like I'm doing with Claude, Claude has all the permissions you do. That means if you have access to the server and you made it so you can log in without a password, that means Claude has access to your mail server. And if you're going to jump in, I was just doing this to show you the power of the terminal, but I really want to caution you as a beginner, really don't set up, yeah, just do that for me. Make sure you're validating what's happening because it has access to your tokens, it has access to your bank account statements, it has access to everything that you can access on that computer. So before you get into agentic AI on your personal laptop, be very careful. Most people that are doing this development are doing it in a safe, protected environment, and it doesn't have access to their life and everything else. So that's the only caveat I'm going to say. I just wanted to show you how powerful this is and why it's relevant for the terminal UI. Um, by the API plan, right? Okay, so it might be helpful to know what a package manager is versus DMG images for beginner Mac users. Yeah. Well, we've talked about installing stuff on your computer. Um, let's continue to talk about how to navigate around, and then we'll take a break. And then if we have time, we'll talk about software management, installing software from the command line, and managing it as a part of it. That's kind of administration. We talked about it a little bit already, but I kind of want to revisit that in a more exhaustive way. It's more important that you take away right now. Um, that what we're doing. I've been talking for an hour, so I'm going to take a break. I'm going to pause the video, and we'll be right back in a bit. After a rather long break, we are back. And I did add a few things here just to let's give you an idea of what's coming. We're going to talk about Unix and Linux processes and how to edit files into the terminal. We're not going to do that today, though. So already we covered, just as a recap, we covered what a terminal is and why you care. Use of it in agentic AI, how to decipher the symbols in the CLI prompt, and the different types of interfaces that you'll hear used. I neglected to talk about something really important, the distinction between a terminal user interface and a command line interface. This is a very subtle distinction, but it's often mistaken and used wrongly. So, a terminal user interface is anything that uses the terminal, anything. So, like these fishies, they're using the terminal user interface, right? And in fact, in a terminal, modern terminal, this is a pretty interesting fun fact in a modern Unix terminal, we're not going to get into the history where terminals came from. I really want to do that, but it would be a waste of your time. If you want a really great rabbit hole, go look at how closely related the modern Unix and Linux terminals are to the teletype machine. In fact, certain devices are still called TTY. And at the end of every single line is a carriage return and a line feed that is reminiscent of the original teletypes. It's a super fun, entertaining rabbit hole. And I'm not going to put you through that right now because that's not going to get you a job. It's just super cool. So make sure you understand that. But when you understand what a terminal does, when you're watching the fishies here, we're watching a lot of little certs. They're called cells, and so the entire terminal is divided into rows and lines, not columns. And is that right? Did I say that right? Is it columns and lines? I can't remember. For some reason they it's not rows and columns though. It's one of them is lines. You'll run into that later. Um And so the point I'm trying to make is every single one of these is made of a cell. You can actually select one. You see how that little cell kind of shows up for a little while? And the cell is, 2 by 1. It means you can, there's two on the top, and then you can actually split it in half. And these little fishies, that's what they do. They split that in half, and that's the size to put a character, right? So the terminal user interface is anything that uses this idea of a terminal, which is divided into, 2 by 1 cells that fill the screen. And you can, look up those things. What is it? Echo lines, I think it is. Yeah, echo lines, and is it rows? I think it might be calls. Is it call? What is it? Lines? Is it rows? Damn it. What's the other one? I can't remember what it is. There's something besides lines. And there's millions of ways of looking this up. And if you want to do some really fun animation, which we will eventually do, you can animate by, you know, putting your terminal into what's called cursors mode, and you can poke and, just like if you're on an old school 1980s pixel, computer, and you can poke the different pixels, but instead of pixels, there are the little cells, and that's how the fishies work, right? And whoops, that's how the fishies work. It's how sunrise works. Watch your eyes. This is how sunrise works. And you can have a lot of fun with this. You can play entire video games just using the text interface. You've already seen how Claude uses the interface to do some kind of cool things. In order for me to change topics on the command line, I use kind of a mixture of the command line and the terminal, which I'll get to that distinction in a second. But I can do T enter, and I can enter in. This is actually a terminal user interface that allows me to type, like, to simplify the number of things until I get to the one I want. It's called a fuzzy finder, and then it picks that thing and changes the topic. That is a terminal user application. So anytime the entire screen is being taken over, or you're manipulating a whole bunch of things that are not just on a single line, that includes that one I just did. That is a terminal user interface. If you are just, is it columns with a full word? Okay, columns. Let me go columns. Yeah, there we go. So you can do the math and everything and center and all that. And so a command line editor like the one I was using, uh, let's see if I can get back there, cd to boost. So this is the same file that I've been working on, docs readme. So this is the same file that I've been working on here, and you can see the same file is in the graphic user interface on the right, and on the left, it's in a terminal user interface. Now, there are advantages to the graphic user interface. One of them is I can click here, and I can do this thing here. That can be done in the editor that I'm using, but I have it disabled on purpose because, but the point I'm making is that this is a terminal user interface. This is an editor that uses the whole terminal. I can go up and down, all the lines change. That is not a command line interface. The command line interface is distinguished from the terminal in that it's only the single command. That's it. So like when you type ls, that is one command using the command line interface. This is sometimes called, um, what is it? Analyze, or what's the loop called? God, I can't remember it now. Uh, print, evaluate, repeat. What is it? Read, loop, REPL. Read, evaluate, print, loop. REPL. In fact, there's a company called Replit that I used to kind of work for, not a, that that capitalizes on that acronym. Put that one in your thing. Replit. A read, evaluate, print loop. In fact, you can write your own command line interfaces, sometimes known as shells, by doing this. Okay, and we're gonna come back to the idea of the shell when we start programming and we start writing in the shell in Bash. We're gonna do that later. But a command line interface, it reads a command and then read, evaluate, and then when you hit enter, it evaluates what that command is, and then it runs it. In this case, it dumps that stuff out to the screen, which we're going to talk about when we talk about processes next week. And then it loops back and it waits again for the next thing. And you can write this. You can write your own shells. You can write your own shells that have these read, evaluate, print loops. That is a command line interface. So I feel like yeah, think of reptiles, right? You'll never forget it. Um, that's a command line interface, right? It's just read, evaluate, print loop, and they're super useful. They're used in all kinds of things. They require a lot less resources than a terminal because you don't have to have this controller behind the scenes operating, where all the fishies go at any given moment. And that's why a terminal in Linux and Unix has two modes. One of them is the ncurses, mode, which is where you can just plot the lines and say where to draw. And the other one is this command line idea of, read, evaluate, print loop. So when you're writing terminal applications, you can decide which one you want to use. You can be really fancy and like the Fuzzy Finder was, or like, the Tmux, or like Claude, or like the Windows selection. See, this is a terminal user interface. I'm picking which window to use. We're going to learn Tmux later, but this is, how I go up and down. This is again a terminal user interface. I've really nailed this point home at this point, so I'm gonna move on. But yeah, all of that uses something called ncurses. If you want to put that in your notes, ncurses. That is the library. That is the standard for addressing the terminal as if it were, basically the thing made of a bunch of cells. Okay, so we've covered that. We've covered graphics versus uh, command line applications. And now it's time to do the last thing before we leave today, and that is understand the file system. Okay, and so the first question is, well, what's a file? Now, we've already talked about this sort of. I think most of you will already know what a file is. Um, Files can be in your graphic user interface. You probably will have something like a Finder, and you can see these are all the files. Mac makes it particularly hard to see the underlying file system by showing you something called recents. Like, for example, all of these files that are here, they all live in a different place. They're all in a different place on the file system. And I have a story about this. So I'll tell you the quick version. I had a mom that was trying to learn how to do tech stuff, and they could not do anything through the file system because they couldn't see anything. And they had no idea what the file system was. And I tried to describe the internet as being a worldwide system of files, and they had no point of reference. And it was because of Mac. Because in a Mac, that makes it very hard for you to see that this file is inside of this directory or this folder, unless you're using the desktop, which I'm not going to show you. But unless you're using the desktop, you're not going to see any of that. But when you get under the hood, so I actually got under the hood, like I'm about to show you, which is in the terminal, and I showed her that, and she immediately said, "Show me that." she thought it was so powerful to understand how to look at all these files and how to do something simple like move all the files that have this string in the name, these letters in the name, from one directory into another one with one command. If not knowing how to do that from the terminal meant you would have to drag every one and go click on them with control and click them all and then drag them over, right? And when I showed her how to do this with a single command, she was like, show me that. So that's what we're going to learn today. Right now, we're going to learn about the file system and how to interact with the file system and how to manage files. I have another story about that as well. Um, yeah, so Windows and Mac are kind of trying to save you from the complexity of the file system, and really, you need to understand it. So the file system is a system of files, and what are files? Um, and this I'm going to use the technical terms for this because I want you to write them down and understand them. You can actually ask your UI, I'm going to do it for you because I want you to get in the habit of doing this. Okay. I'm going to make a new query. So I did Command N and I'm going to say, what is the Unix file system? All right. Now I'm going to talk about this, but I'm really curious to see what this would show you. Did I click my update button? Please come back, Chloe. Chloe, come back. Where are you? Okay. So I did the little upgrade thing. What is the Unix file system? So let's see how well she explains it, and then I'll tell you what I think it is. Pipe anything. Okay, you don't know what pipe means yet. Then by Windows is a file cabinet with labeled drawers. Unix is more like a living tree. This is stupid. Okay, good thing I asked. What the file system is a system of files, and every file, it can be a different type of thing. Mostly it can be like, in this case, we have text files in here. And so you know, I'm going to use all these commands and we're going to explain the commands. Okay. Um, and you can see what the files are. You can use their commands like file, that will show you what type of file it is. You can do a file on docs and it'll tell you it's a directory. Okay. Now we're going to use these terms. So a file is anything in the file system. Now, the part that's going to break your brain a little bit is that everything that's in the Unix file system is a file, including the directories. And hear me out. Okay, so in Unix and Linux, a lot of people will not explain this to you, but I want you to understand this. Um, all of this stuff is, you can imagine if you've ever used a spreadsheet, okay? If you've ever used a spreadsheet and you've got a whole bunch of columns and rows, right? And you put things in that spreadsheet, and then you have another spreadsheet, and that spreadsheet's got a bunch of things in it, right? And maybe one of the columns on one of the spreadsheets points to the top of that other spreadsheet, okay? And maybe one of the things in one of the spreadsheets points to a single item in the other spreadsheet. That is exactly how the Unix file system is implemented. And under the hood, they're called tables or file system tables. And it sounds like Chloe doesn't know about that. She doesn't know how to explain it. But these are, you can think of them as if you had these sort of spreadsheets that had lines and rows, and each list, each one had all of those things in it. So when I do ls to list all the items in here, you can think of this as listing every one of those lines inside of that sort of table, we'll call it, right? And that table, each one of the items in the table is called an inode. Write that down. Nobody will teach you this in your first year, and I'm going to teach it to you. Okay. They're like, oh, it's just all files. No, it's all inodes. And the reason this is important is because everything in Unix and Linux is an inode. And I mean everything. Everything. The display terminal adapter, the each one of the devices and processes, the network connection to the internet, every single one of those things is an inode or is a virtual inode. And it is so critical that you understand this at every level. At every level, you need to understand this. When it comes to understanding how to manage the file systems, when it comes to understanding how to deal with them when they get too full, or whether they're running over the network and it's not really on your computer, and or if you run out, that table, guess what? It has a limit. You can run out of space, and all of a sudden you get errors that say can't write any more inodes out of inodes. You're like, what the hell is an inode? Well, now you know what they are. An inode is an entry. It's one entry in a table that represents, and I'm that part. That part I'm oversimplifying, but I want you to get your head around it. That it's table. It's one entry in the table for this specific directory. And each one of those lines, you can have items in that table that point to other items. Okay, so that is that is super important that you understand that. Okay. So now that we know that, I can describe to you the difference between a file and a directory. And when I said everything is a file, what I really meant to say is everything is an inode, but you didn't know what an inode was. Now you do. An inode is an entry in the table of things that are here. And those things there's many different types of things. So one of the things is a text file. And so we have readme.md, and you can actually use the file command, write that one down. The file command will tell you exactly what type of inode it is. It'll say, is the readme file, what is it? Okay, the readme file is a Unicode text file with very long lines, blah, blah, blah. Now, if you were to actually look at the inodes in the table, and there's commands for that, but if you were to look at the actual inodes in the table, it would show you the file type, and you could figure that out. Um, not for the red, yeah. So there are many other file types. So here's I already did this once. We'll do it again. So as you can see, the docs directory, and to help us, it's also showing us here that the color is different. But this is what's really important. You see this thing here? This tells you that this inode, because directories and files are so common, that tells you the type of file is D, is a directory. Okay. Now, once a file becomes runnable, that means it becomes a program that can be run. So we'll type which ls. There's bin ls. So if I type ls/bin ls, you'll see that this is a different type of file, and it's also red. What's up with that, right? This file is an executable. And we're going to talk about permissions at length later, but what I want you to see is that even though this looks kind of the same as this other text file over here, it's a different type of file. Now, I don't think this has a different inode entry type, but you can actually look at it this way. You can use the file command, and you can see exactly what type of file it is. This is the file command, and understanding what type of file a certain thing is critically important if you're a hacker, because this will be all over on the hacker tests, because sometimes people will try to make a file look like another type of file, and you can use the file command on the file to see what it is. And I actually did this to catch a hacker who broke in to my mail server in 2000, and I actually reported them and everything. That was fun. I'll talk another day. I'll talk about that. Um, because they had put a file into a different place, thinking that I wouldn't find it. So remember how I said everything is a file? Well, let's look at some really weird inodes. And again, this is not something any book is going to teach you in the first year. I think you should know it from the beginning. And so let's go into the nethers of the Unix file system. We're going to go into /proc. Now we don't. Whoops. Is there no proc because we're not on Linux? I forgot. What is it? Is it slash? What is it on Unix? On Linux? That's okay. Let's do Linux because I know it. If you're on WSL2, you can go into /proc and it'll work. What is it on Unix on Mac? I don't know. I usually use Linux for. Let's do Docker Podman. No, let's do Podman. Run it. Let's do, what should we do? Nora? Let's do Kali. It's prettier. Kali Linux. Yeah, let's do that. All right, so let's see into /proc. All right, so this doesn't exist on Linux. I didn't know it didn't exist on Windows. Windows, okay. WSL is Linux, and this container is Linux. Um, Mac is Unix, which is very close, but they're not the same. So, but as far as in terms of like coding and stuff, you can do everything over there. So, but in slash proc, what I wanted to show you is everything's a file. This goes for Unix too. I just don't know the location on Mac. Um, so you see all these different things in here. They look like pretty interesting. It's like they're owned by nobody. What's up with that? Wait, what's what? There's like lots of different kinds of things in here. Um, slash proc doesn't actually exist, and the other 3 days they're all on YouTube. So, um, and so the the slash proc is what's called a virtual file system. That means that the kernel, the Linux kernel, is providing you command line access to stuff that it knows about in its running kernel in memory. It's running inside the computer. And so this is all of this stuff here. It looks like it's a file system. It's actually not really there. And it's called a virtual file system that's provided by the kernel so that you can interact with the system itself. The thing that's really amazing about this is why it's so important that you understand file systems in Unix and Linux, because everything is a file. You'll hear this over and over again. That means, and I don't know, I'm really, really not kidding. When you write low-level software that needs to interact with the kernel in some way, like to deal with processes, which we'll talk about next week, you're interacting with the underlying file system. The proc file system, everything interacts directly through the proc file system. There's not the system calls, everything that needs to be done operates against this virtual file system. So the interface between everything and what is actually in the brain of the computer under Linux and Unix is through files. It's through the file metaphor, the file paradigm, I suppose. So um, yeah. So these are all the different things that are there, um, and they're dynamic. So, we'll get into more about what those all are, but they're actually not really there. So most of the time when you're dealing with a file system, you'll be dealing with one just like we are here, and you'll be dealing with files and inodes, directories and files that are actually being stored on disk. And at the risk of losing you, I'm going to show you what that means. So if you type um, df, it will show you the disks. So there's a command you can put in there. And this is pretty much the level of complexity that I want you to understand before we go down the really deep rabbit hole of mounting file systems and virtual file systems and all that stuff, right? Most of the time, most of you understand what a hard disk is. A hard disk can be either real, like actually hardware in your computer, or it can be virtual, which means it's, there's RAM, which is, how much memory your computer has. And that a bit of that RAM gets turned into what looks like a disk, even though it's not really a disk. And that's the difference between virtual, um, a RAM disk, they call it. But in every case, anything that you're going to interact with that has a way to be stored, that doesn't include slash proc, right? That stuff is all virtual. Anything that can actually receive something and store it temporarily or permanently after your computer gets turned off has a device, and that device is also a file. You see where this is going? A device is an inode. In fact, you can do file dev disk 3 s1 s1, and it will show you that it is a block special device type. Remember I talked about the tables and the inodes? Well, under dev is another virtual file system. That means it's not real, but it represents all of the hardware devices on your computer. When I said everything's a file, I mean everything is a file, including the hardware devices in your computer. They're all addressable as inodes in a table, as I just showed. So dev disk at disk 3 S1 S1, this is an inode. It's a virtual inode, but it's still there, and that represents a block special device. Block devices are devices that can be written to and can be stored, you can pull stuff out of them. And we don't need to get into the different types of devices in the IO. We'll do a little of that, but you just need to know that it can be written to and it can be written from. And the df command shows you a bunch of things like how much room you have on here. If you don't know about size and bits and bytes and all of that, we will get into that when we get into coding. In fact, we'll talk about binary, but this just, it just how much room you have on your disk. The short version of this is that um, the files are all written in zeros and ones, and if you combine 8 of those, 7 of them plus one for plus and minus, together you get 1 byte. A byte is called byte. If you have if you do, two, I'm gonna get sucked here. If you do more of those, then you get, a kilobyte is probably what you're going to hear about. That's 1024 of those. Um, People make mistake all the time because they'll do 1,000 versus 1024. It's all, by the way, these are all factors of two, right? Two to the first, two to the second, two to the third. Um, and you'll understand why that is when we get into coding and we understand binary just in general. But that's what's going on. So, and then, so you have kilobytes, and then you have megabytes, which is 1024 kilobytes, and then you have gigabytes, which is 1024 megabytes, and then you have terabytes, which is 1024 gigabytes, and then you have petabytes, which is 1024 terabytes. Did I do that right? And you go all the way up to something called the Googleplex, which is where the term Google comes from, which is like just it would take you a lifetime to just write the number. Um, so yeah, but this is all important to you. Why? Because that's what these numbers represent, right? So when you see 205 ki or kilobytes, you know that that's significantly less than 460 gigabytes, right? 12 gigabytes is here, and you probably already know about a lot of this, but it's like how much do I have free? Okay, so this is what I wanted to show you really quick. You see here it says I used and I free. That's how many rows of inodes are available in that table or in that overall file system. So I kind of lied when I said that there are multiple tables. There's really not. There's really one big ass table. Okay? There's really one big ass table that is this file system, and this tells you how many inodes there are. And I wanted you logically to think of it in terms of like separate tables, but really they're all there, and the one is just referring to another one in the same list. So it's just really big table. Um, and it does have a finite capacity, right? Not in terms of like size used. Here's a fun fact for the veterans out there. Did you know if the I think it's 1024, if the length of a text file or any file is under a certain amount, it doesn't even create an entry on disk for it. It puts it all into the inode. I'm gonna actually. Um, this is a really interesting side note for people. You can sound intelligent if you bring this up with a veteran. So, what is the maximum bytes? A file may have and be stored entirely in the inode and not a file and not another inode and not on disk. Um, this is next level nerd stuff. Fast symlink inline data. 60 bytes. The max base size is based on the size of the inode minus this metadata field, so it's system dependent, not typically. So 60 bytes, sometimes up to 160 bytes. So, okay. Remember I told you it's like a table, right? Every single one of those things has when it was modified and a lot of information in it. But there is, it looks like up to 60 bytes. That's 60 times um, uh, eight individual ones and zeros. And if your data falls within that amount of space, your the entire thing is written into the inode table by itself instead of to a separate file that the inode refers to. The thing that's super interesting about that is if you can make a file that's under that amount of size, then you have zero disk IO because the inode table has probably already been loaded. This is super important because a lot of people will think that these files that have well, people creating a lot of files that only have one line in them is a bad idea. It's actually totally fine because those are all much faster to interact with. You should probably not be thinking about that, but it is kind of a fun little side note. Um, so let's go back. So here's all the disks that are on, and the disk is you can see it's been one disk has been chopped up into different pieces. And you can see over here where those pieces are mounted. Um, and with yeah, so um, let's talk about mount points. So this is a device reference, and in Unix and Linux, all of the devices, block storage devices on which you can write something, are mounted. And what that means is there is an inode, there is a place you can navigate to that has been mapped to this device. And that is the root of that thing. So if I go into this place, I am going to be modifying this device right here. And it looks like, oh, wow, Claude made its own volume. I didn't know that. That's interesting. I wonder if that's an install or it must be an install. Anyway, but knowing where a thing is mounted is important. And I won't get into it, but it's very common to mount. And by the way, it doesn't just have to be a directory. You can mount a device to a file, which is some weird stuff, but you can do that. Um, if you can actually mount a file system on top of a device that already has stuff there, and it can be interesting because you can actually shadow something that's actually there by mounting over the top of it. It's a pretty interesting hacker technique to attempt to hide. Um, Anybody that knows anything would easily see around that, but that is something that is done is to mount something on top of the actual thing that's there. And then it kind of hides it from everything that's looking in the system. And that brings us to the important thing here. How do you actually look around? So let's talk about the ls command. So the first, you have a general understanding of what a file system is and how to interact with it. And I think you could understand if somebody was talking about the file system in your presence. Um, and so the next step here is to understand how to see this stuff. So the first command we're going to learn, and you need to write all these down, is pwd. Pwd prints the current working directory. Make sure you write that down, pause the video, whatever you have to do. About covering something it was mounted. Yeah, everybody learns that the hard way. That's why I mentioned it. It's like you can't find a thing under there. So yeah, when you get into when you start mounting your own file systems, let's say you add a hard drive to your computer and you're going to mount something, it's very common to mount the wrong thing. So that's not in the beginner boost though. We'll when we do more advanced operation stuff, you'll need to know that. As a beginner, you just need to know what the file system looks like, how it gets mounted, and how to deal with that if that becomes an issue. Every single technologist out there who wants to do engineering, whether it's a software developer or an operations person or just a DevOps person, you have to know this stuff. You have to at least know the concepts. And people don't talk about it. So here's the present working directory. Okay. Now we can actually do some fun things here. Let's run mount really quick. And this shows you where everything has been mounted. So, okay, so we see that slash, we're in slash. So which file system are we on? Well, because see how it says system volumes, blah, blah, blah. Because we're users artifacts rob, blah, 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 we can see that we're under root. So we're currently writing to this device. Okay. So PWD, um, uh, you're about mounting, about running, about mounting the wrong thing. Yeah. that shows you where you're at. So if you ever get lost, you'll see me typing pwd all the time because gives me a sense of security. I know where I'm at. Um, and the other thing that I'll do a lot is cd or ls. So ls shows you what's in this directory. And if you do ls-l, that will show you all of the things that are in the directory. And it's about at this time that it's important that I show you something else. I'm going to put this in here. Uh, and so I'm going to show you yeah, no, let me try one other thing here. Okay, so we're going to say uh, looking up help docs or commands. So this is kind of one of those things at where you can use the man command, you can use the help command, you can use info, and you can just use your AI. All right, so ChatGPT is really good at doing this. If you don't, in the old days, you didn't have AI, so there's a command called man for manual, and there's kind of a running joke called read the fancy manual. Only they didn't say fancy. Um, And you can actually print these out. I'll never forget the first time I worked for a company where the guys, first time I'd ever seen Unix, they had all of the Unix man pages printed out in spiral bound uh, things in the Raptors, and they would pull them down and they would flip through them. That's how old it was. But these days you don't need to know that, right? If you're trying to find a command, you could go to your AI and you could say, um, how do I list files from the command line? And you could just ask the question. I'm simulating what you would probably do. SHSLS. You're going to get a whole summary, and you're going to get the short version of it. So I'm going to strongly encourage you to burn tokens and use AI for your commands. And that's why I just want you to know the commands so you can know what one to ask about, right? And by the way, if I hadn't put the commands there, you could have just done look up help docs for the commands if you want to know how to do that, right? But otherwise, you could say, what is a file? What is a directory? Everything is a file. Everything current working directory. You could do a search for looking up the current work directory, and it would tell you the command and it would summarize it in a much more digestible way. So this is what I'm trying to show you. If you go to the AI, you get this really happy summation of the main commands, the kind of thing I would tell you, or any mentor would tell you. They wouldn't tell you everything that's in the man page. So let me show you the difference. If I do man ls, this is what you get instead. And as beautiful as that is, and as wonderful as that is, and this is a thing that we had to read through. We had to digest all of this. And in 2026, this has all been digested for you by the AI, and the AI is going to give you a much more digestible, readable version of this. One of the rites of passage was to go slog through this thing and read about every single command. How many commands did the AI tell me about? Manual pages are designed to be exhaustive resources that have all the details, and sometimes reading those details is a good idea, such as learning about command line completion with Bash, which I only discovered through reading the man page. No, it wasn't in any book. So sometimes it does benefit you to read through how many pages are we on now, right? The whole entire page. But most of the time, you should ask your API, your GPT, Chat GPT and or Claude, whichever one, and it will tell you what to do. Recursive listings. Oh, this is cool. It gives you a modern take on LS, probably written in Rust. I didn't know that was the thing. Older, more common EXA. What is that about? I've never even used that. Is that even on here? She's hallucinating. I don't have it. EXA LS. Way cleaner output shows get status. What? I'm gonna try this. Okay, just know if you're gonna put it on your machine that it's not going to be there on the work computer. So don't become dependent on it. Yeah. All right. So as a probably some. Oh God, look how pretty as a ls as a dash l. Wow, look at how pretty that is. The original product as a continuation of the pork. Okay. Well, I mean, does is it completely compatible? If it's compatible, then you could just turn you could alias your ls to it. Too much color. It's way too readable. I don't think it even has hard links. No, it doesn't. Oh no, it does. It just moves over. No, it doesn't. It doesn't have hard links. Apparently, they didn't think hard links was important. Yeah, that's typical. That's typical of a rewrite it in Rust project. They don't care about hard links, apparently. This number here is not hard. It's hard links for files, but for a directory, it's how many files, how many inodes are in that directory. Mm, okay. So yeah, but I mean, again, this is what I found it. I found it in ChatGPT. So what else we got? So we got ls. Ls or ESA if you want is how to look at stuff. You've got to know ls people because there's not going to be any ESA on your system container, right? And you don't want to install stuff. You're going to find this is a recurring theme with me. Learn how to be productive, then screw around if you want. Okay, so um, we learned PWD. So PWD just shows you the current directory. I don't use it for anything else. I've never used any of its options. Display the logical current working directory. That's interesting. Did not know that was a thing. Oh, wait, there's a version that'll resolve symbolic links. By the way, some of these commands are different on Unix from Linux. Very, very, very important distinction. In fact, let's look at that right now. So this is on Mac, which is Unix. So there's a dash capital L and there's a dash capital P. I'm just super curious. Let's see what that looks like on Kali Linux. So if I do pwd-h, oh, it has LP support. Okay. So in this case, it does have it, right? I know for a fact that ls has different options. So ls-h, oh no, that doesn't have it. Man, ls, it's not gonna have the man pages. Containers usually don't have the man pages because why? It's a waste of time. So again, probably another reason to not become dependent on man pages because they have to be installed extra into containers. You're going to be usually working in a container, so you're going to have to go to a single similar system and run man if it has a man page. So might as well just punt and go to your AI and ask. So it's usually going to be the regular thing to do. Um, and all right, so there. All right, where are we? Okay, so we learned how to look in the current working directory. Where am I? We learned how to list the things that are here, ls and ls-l. Um, there is one other option you should know, and that is ls-al, and that lists everything. So now we're gonna understand the concept of hidden files. So everything is a file. Look up the current directory list, everything in a directory. Okay, so if you just do the ls-l, it doesn't show you the hidden files. So I think I'm going to put here, I say, understand hidden files. So in Unix and Linux, any file that begins with a dot is considered hidden. That means, especially if you're using a GUI, it won't even show up. But it's there, right? And it's a way for you to make files that are kind of out of the way, um, kind of invisible when you're just doing a normal OS, and so you don't end up screwing with these important files. I'm in a GitHub repo, so .git is a very important hidden directory that contains all the information about this Git repo. There are two more things here, and this is important you get this. Uh, let's see, look up everything, look at current directory, understanding hidden files, understand dot, let's say current directory is a dot, parent directory is dot dot. All right, and the reason this is important because you will actually use these references. Dot refers to the current directory, the current inode, and dot dot refers to its parent. And these two things are actually, if you were to look at the row of inodes, they are written in there. The parent reference is written in there, and that's how it knows to go to the other entry in the table. And that's what dot dot. So just think of dot dot as going up one level and dot as being the current directory right now, this one right here. You might think it's not important because you could just type, readme right away because it's in the directory. But there are certain times when you need to explicitly say dot slash, and we will get into those later. So it's important that you know this. Um, so we've talked about hidden, we've talked about listing out all the things, we've talked about directories. We haven't really talked about permissions yet. We will. Um, and the next thing, okay, so we've listed them out. We've shown where you are. Now we need to talk about how to move things around and stuff like that. Is there a difference between PWD and dot? Yes. PWD shows you the full working path. That means the whole path from whatever file system you're on all the way to root, which is slash. And it shows you how to get all the way to where you are. Um, almost any time that you're going to use dot instead. So dot is relative, right? Dot is relative to your current location. Um, but PWD is also relative to your current location, but it gives you the whole path. And this will become important later because when you want to write a script, you could do, there's another environment variable called PWD, and that will show you the same thing that it'll tell you essentially what dot is, but you could also use, dot slash, right? So when we get into running programs and stuff, you'll see that a lot. Okay, so next we have working with permissions. We talked about permissions a little bit. Um, so we haven't talked about creating a file. So let's do that first. Create a file. There's lots of ways to create a file. We're not going to get into redirection and all that. If you want to just create an empty file, just an empty file, totally nothing in it, you can just type touch. So you can say touch my file. And what that does is it creates a new file and it updates the date and time on the file. So we talked about an inode, but we didn't talk about all the things that the metadata in the inode. So that includes permissions, which we'll get into, but an owner, but it also includes when the file was last updated or when it was created. So there's last updated, when it was created, originally created, when it was last updated, that means the file was changed, and then there's when it was last accessed, which is a different thing. And I think those are the main date stamps that are in an inode. Actually, let's ask the AI. What are all the metadata fields in an inode? I kind of want to know this. Now we're getting into the good stuff. There's a unique identifier. There's a device ID, which system is inode it lives on. Mode is permissions, file type, regular, directory, symbols, etc. Yeah. The type is permissions, the bits. This is where RWX Rob comes from, by the way. Special bits, the set UID, set get ID, sticky. We talk about special bits later. The UID, that's the owner user ID, and the GID, the group ID. And it is pretty verbose, yeah. Line tracking, link count, how many hard links to the file, number of hard links pointing to the node. We already showed that. That's what these numbers are right there. Size and storage. You know what I just realized? Oh my God. I just realized that the reason the number of hard links, this is the number of links to the file, the reason it's 23 here for a directory is because all the contents of that directory hard link to the directory as its parent. Oh my God, that's the first time I ever noticed that. I used to think the way I'm saying is that Docs has 23 files in it. But what it really has is it has 23 references to itself inside of it. Those are other inode entries that refer to that as the parent. That's cool. I hadn't really made that association before. I always thought, oh, the number is different for a directory from a file, but it's not because it's the number of links pointing to it. So those are hard links. Those are hard links to the parent. Interesting. So anyway, size in bytes, block size, preferred IO block size. The number of disk blocks actually allocated. So a disk block is different than how big the thing is. That's because when the storage gets allocated, it gets allocated in blocks. And if it's under that block, then it'll give another block. Timestamps, the Holy Trinity, A time, M time, and C time. Those are the ones I was talking to you about. Um, Modern systems has creation time. So yeah, it's not POSIX. I didn't know it wasn't POSIX. POSIX is a standard for Unix. It's been around since 70s, I think. Um, Data pointers. Classic Unix inode layout includes 12 direct block pointers, one single indirect pointer, and one direct indirect pointer. ext specific. Yeah. It depend the file system type. There's like we're using ext4. That's the software that implements the file system. Immutable, append only, generation of array cells. Yeah. Wow, there's a lot in the inode these days. File names are not in the inode. Really? I didn't know that. The directories have the ID as a number. How does it look up the name then? Where do the names go? Well, that makes sense too because the inode is unique. It never changes. You can change the name of a file without changing its inode. Okay, where are the names to the inodes stored? I know we're going way off the deep end here, but this is fun to me. The names are stored in directories, not in inodes. What? Oh, okay. So inside of a directory inode, I thought a directory was an inode. It says this file is this inode. This file is this inode. The directory's data block store looks like this. Oh, isn't the directory itself an inode? It is. I know it is. I just want to hear her say it. Every file type in Unix is just an inode plus data. What changes is what the data means. Oh, so an inode goes to metadata plus pointers. The directory, a directory has a data segment that has the structured entries. Interesting. The directory itself is just another inode. But it has the name to inode change. So when you change the name, you're actually editing the data structure of the inode of the directory, which makes sense. I mean, if you had a table and you'd have to change, it's just like you're going in there and you're editing the name. That's super interesting to me. I don't think I ever looked that deeply into it. And you know what? ChatGPT makes it super easy to do that, especially stuff like this. This kind of stuff is well established, so it's unlikely that you get hallucination and freaky AI interactions. So anyway, so yeah, we learned a lot about inodes. We learned about files, probably way more than you wanted. All right, so we learned how to make a file. Let's remove that file. So to remove the file, there's lots of ways, but the main way is rm, remove my file, and now we do an ls. You notice that doesn't say anything. It's really important that you go do an ls after that to check that it actually happened. And so that's how you remove something. I think I put that in here, but I want to check. Remove a directory file. So let's actually do that again. We're going to go make a new file. Don't worry, we're going to do more things with files next week. Once we learn about processes first. So let's touch a file again. Let's touch a new file. Let's touch another file. By the way, you can put spaces in the names and stuff, but it's a bad idea to touch horrible name. Horrible name here. And when you ls, you see that it's like really hard to tell what it is. And if if you tried to remove that file, how are you going to do it, right? You can't, if you type horrible name here, it's not going to do it. In fact, that could be super dangerous. If you did this, it would remove the file named horrible, the file named name, and the file name here, which could be super dangerous if any of those files actually existed. So the way to get around that is to do this, to put quotes around the whole thing. Oops. And God, Robert. And I'm pushing the up arrow, by the way. We haven't learned about that, but we will. So now you go see if it's there, it's gone, right? Another way to do that, by the way, so touch horrible file name. That's actually going to touch, you see that? That touched 3 files because it took each one as a separate file name, right? So I just want you to see this. So, and this is all coding, by the way. You can, and this is really weird, is you can actually have a horrible file name that, and then you have, if you wanted to delete it easily and if you run across this kind of thing, you can do this. You can do rm horrible and hit tab. Now, you see how it completed out to that line? Well, if you hit tab again twice, it will give you all your options, right? It's like, okay, you can just stop there and delete that one. But if you want to get that space in there, you can't just type space because you can't see it. So you'd have to type backslash space. I'm trying to make you feel the pain here. You type backslash space and then tab, and it will find the entire file name. Now, if that other horrible wasn't there, then it would be much easier. And I type horrible and tab, and now it knows which one I want. I'm not removing my home directory, and it actually escapes it all for you. So, um, the moral of the story is don't use spaces on Unix and Linux in your file names. I mean, really, strictly speaking, the file name can contain anything, and I mean anything. And there are lots of ways to hack a system. You can name files question mark. You can name files dot, even though you already have a parent. You can name files dot dash a, which is going to conflict with the command because then you're not going to be able to do anything with it. And you have to get really crazy when you're doing any of that stuff with that. And so that, that's kind of that. So we've created a file with touch. Let's do it one more time. Let's remove file and name at the same time, which this particular command takes multiple things. And we've got that. Now, let's make a directory. And that's a different command. Make dir. Make dir a dir. And now we have a dir. Now, if I do rm on a dir, it won't do it because it's a directory. Now, hear me very carefully on this, okay? Do not remove directories with the rm command. And I know somebody's going to complain and say, what are you talking about? Trust me, do not remove directories if at all possible. Try to use the rmdir command on a directory. Hear me out as to why. If you put something in a directory, this will save you so much pain and suffering. So I'm going to touch a file in here, touch a dir, a file, and I'm going to touch another file. And now if I ls a dir, you'll see that there's 2 files in there. Probably time to introduce you to the tree command. You can use the tree command and it'll give you kind of a graphic representation, brew install tree, if you want that. It's kind of nice. But that gives you what's in there. Now, if you remove one of those files and you do, let's say you think you're cleaning the directory out, right? And you try to remove the directory and like, nope, you can't do it. That's for a reason because the directory is not empty. And I actually just ran into this. I made a video about how stupid Claude was because Claude did not know to check a directory to see if it had files in it before it removed it. And it used the very, very dangerous rm-rf. What that does is that recursively deletes the directory and everything in the directory. It's one of the most dangerous commands in all of Unix and Linux. Everybody watching this who's a veteran has deleted something really significant on accident doing this command. Don't use it. Don't use that command. You can get away without using that command unless you really know that you want a whole directory going. But most of the time, what you really want to do is this. You want to remove a dir, and then you want to get rid of one of those files, right? So you say a file, and then you go, if you get into the habit of using rmdir on a dir, you're like, oh yeah, that's right. There's this other file in there that I forgot about. And so by forcing yourself to use rmdir, unless it's really laborious because it's multi-levels deep or something like that, um, make sure that and then you could like if you remove the other file, you hit tab, you got that file out of there, and then you rmdir adir, and you can remove the whole thing. Okay, so that is a much safer way to do that. Um, of course, the alternative to that, that's nice and quick and dirty and super dangerous, is rm-rf, and then to point it at that file. Um, and before you go recommending to some streamer that they do this against slash, let me show you what would happen if you tried that. Don't do this on your actual system. Do this in a container. This is what containers are for. But I want to show you how stupid you sound when you tell people to do this. Okay? I am sick and tired of people trying to think they're really smart and come into my stream or another noob stream and tell them to do this because they obviously haven't tried it within the last 10 years because it doesn't work because it's so dangerous. And let me show you what I mean by that. So if you do podman run it. Let's pick Kali again. Kali Linux, rolling latest. All right. Okay. Now we're in the root directory and we're going to rm-rf, slash. It says, nope, sorry, RM is too dangerous to operate recursively on slash. Make sure you do no preservatives file system. So before you go proving how stupid you are sorry, not stupid, inexperienced you are, at least know that recommending that doesn't work and it hasn't worked for more than a decade. And the fact that you're recommending that to somebody means you've never actually tried it in a container, probably because you don't know what a container is. I'm sorry, that's a little bit harsh. I am so tired of beginners doing this, and the next thing that they always pop out is how to do a fork bomb, which I will not repeat here. People in the chat love trying to flex, and I'm just trying to tell you, if you try to do that, it's the opposite. It's an anti-flex. It just shows that you're an idiot. You're not going to test it anyway. If you're in a container, test it. You can do anything in a container. You can't hurt anything. You can't. You can't hurt anything in a container. If the container, unless you have mounted stuff specifically into a container, which you'd have to explicitly do, you're fine. That's what the containers are for. I ran that on VPS, so I was about to stop paying for it. Yeah, just for fun. To be fair, I have run that on a live system before. That's hoodies all day, son. Yeah, I know. They're everybody's got them. They're like, hey, this is so cool. I'm like, no, you're an idiot. That hasn't worked for a decade. Anyway, so that was that was a huge distraction, but hopefully it'll pay off one day. So we created a file. Okay, let's talk about permissions, and then we'll be done. This has been a long boost, but whatever. So ls-l. Now, without getting into all of the stuff about permissions, we're just going to talk about the basics. So the basics are you get a special bit, this right here. This is a special, this tells you something special about it, right? So you remember the symbolic links, they had L there, meaning they're a link. D means that it's a directory. There are other special things here. Like if you go into /proc, you can see stuff there. And then we have three different properties, and these are all stored as an octet. If you know what that is, that's 8 bits. And they are read, write, execute. So the first permission is read, write, and possibly execute, right? And this is for the user or the owner. And the second one is for the group. And the third one is for other or world, everybody else. Thanks for the follow. And this here is the owner. So that's who gets these permissions over here. And this here is the group. So that's who gets this. And it's something interesting you can do here. You can actually give the group 0 permissions. And if they're in the group, that means they can't see it. So you can make groups that you can deliberately make it so that that group can't see the file. all of this, user group world stuff was way, way, way more important when we were on systems with 16,000 users at a university. Big ass, AIX and Solaris machines. That doesn't exist that much anymore. It still does. Like if you do Pico CTF, which is sponsored by Cambridge University, you'll see, you can go over there and you can have, there's this big multi-user systems that you can have all kinds of fun with other people on. Same thing with another one called Over the Wire. All multi-user systems. You can actually directly manipulate another person's session using PTY, which is really fun if you really want to play with people over there, because they haven't set up their permissions very well over on that particular open system. It's really fun. You can go listen to all their keystrokes and everything, all kinds of good stuff. Multi-user systems are dangerous, and they have been for a very long time, and that's why we're not seeing them anymore. What we see now is we see single containers that are totally contained away that do one thing and can be thrown away, nobody cares, and usually they're running as root because nobody cares because it's just root on that system. It's being contained in an outer system that's sort of protecting it. And Kubernetes, if you've heard of it, is all about running a ton, like literally tens of thousands of these little these containers as pods, and then doing all kinds of fancy things, usually as root. So the age of the use of permissions and stuff has kind of changed. If you're on a jump host, which means you have to log into a single multi-user computer in order to do your other stuff, then having multi-user permissions is a thing. But otherwise, it's usually not as important as it used to be. Um, and as I said, that's where RWX comes from in my name, RWX Rob. Um, this number, if you want to know, you'll see people represent that number as 7 we're going to use a symbolic method of doing this, which you should always do, by the way. I am so tired of veterans telling people, oh, just do 644 recursively against the directory. That's like, yeah, if you want to screw up every directory, because the numbers for the octet have different permissions depending on what the thing is, whether it's a directory or it's a file, right? So if I want to we're going to get into how to change these permissions. In fact, I think I'm going to skip this just so you know the command is chmod. And if I wanted to lock down another file so that only the user can see it, I would do chmod. There's lots of things to do here. I would do chmod user equals read write, and that would override all the other permissions. And then when I do us-l, you can see, wait, what? Oh no, I need to do the other ones. I need to make it so that the other ones are not there. Actually, I think, well, let's do two things. Should we delete all of them first? Okay, a user, is it group? Let's do group equals dash, and then is it other equals dash? I'm trying to do symbolic. Yeah, that's it. Okay. Uh, yeah. After the X, I don't know what the add is. I don't know what that is, honestly. I never known. Okay, so that's how you should do it. Now, why? Because, you can set permissions explicitly about that. Ask your AI about Shmod. Okay. You will see tons of people, probably your AI, that will tell you to do this instead. It'll say do 600 because it's faster to type. All right. And the reason for this is because it's the same thing. And in order for you to understand this, you have to understand bitwise mathematics, but just understand that a 6 is read write. No, I get that right? Yeah. A 2, I'm going to have her explain it to me because I don't want to get it wrong. 4, I think 4 is right, 2 is read, um, and 5 is execute, 7 is executable. So it's like an addition of all the numbers. And the reason the numbers are that way is because if you were to look at all the bits in the 8-bit thing, if you turn all the bits on, the number you get out of that when you convert that to a number is 7 or 5 or 6 or 4 or 2. And so yeah. Yeah. I mean, I have to look up the numbers every time. I know that 6 is read write. I know that 0 is nothing. I know that 4 is read, and that means that 2 must be right. So you add 4 and 2, and you get a 6. That's read write. And I know that 7 is executable and read write. So that's 6 plus 1. So that must be the extra bit there. So, but if you don't want to remember any of that, you can just do, if you want, like, for example, if you want to make this entire file executable, you do chmod plus x, another file, and then you don't have to remember it, and it just makes it executable. If you want to take away execution permission, you can just do minus another file. And people try to look cool by remembering the numbers, but the reason the numbers can be dangerous is that whenever you start doing this recursively, the permissions on a directory mean something different than the permissions on a file, which we're not going to get into today. You can go through that if you want. Or you can ask your AI about that. We're really going to get into the executable thing when we start to write code. And, spoiler alert, your file has to be executable to run. Or does it? Stay tuned. When we get into coding, we'll talk all about that. Okay, so work with permissions, move file or directories. Okay, link one file to another. God, we have so many things. Let's talk about moving files or directories. Okay, so if I want to, let's talk about renaming first of all. Renaming file or directory. Okay, so if I want to rename another file here, the command is move, MB, and so I can move another file into a new name, and I can type lsshl, and it will lsshl, and that will show up. Now, the problem with this is that it also moves the file. So the same command for renaming a file is the command for moving a file. And I guarantee you there's veterans out there who have done this before. They've meant to move a file into a directory and the directory doesn't exist and they end up renaming the file. Let me show you what I mean by that. So like if you think that let's say you get the name wrong, right? Well, let's try it. Let's try that. So if I try to move new name into docs, but I type too many S's, right? Many, many, many times. Yeah, people who've been around the block have done this. So you're like, wait, what? It didn't move my file into the docs directory because you misspelled docs. And now what? Now your file's been renamed because it did what you told it to do. I really wish they had another version of the move command for renaming things, but they don't. So you're gonna do that at least once. Now you know not to do it, right? You have to change it back. No, I didn't even name it right. So move, rename, original, orig name. All right. So it's same as SP, right? So um, so you're from the command line. You're gonna move the original name. We want to move it into docs. So to do it right, I would do this. I do move a rig name into docs. And if you hit tab, this is another thing. Tab is going to become your best friend because tab is like, oh, what are my options, right? Docs tab. And then you don't make the spelling mistakes. And it puts a slash, nice happy slash after that. So you know what's happening, right? Um, and now it's like, where did my file go? It doesn't tell you it moved the file. It just expects you to know that you moved the file. And yeah, there's been more than one time where I moved a file to some place I didn't know about, and I was like, where the fuck did I put my file? Which brings me to the next command, find. So how do you find something? So find is the most powerful command in all of Unix, I'm convinced, and nobody knows about it. Find dot. So we want to find in the current directory the file with the name orig name. But let's say I don't remember the whole name. I'm going to put dot and I'm going to put orig. I know it has a rig in the name, orig star name. That will look through everything and it will give me, oh, look, there's other things called orig in there. If you move on top of an existing file, right. There is, you can put no clobber. You can turn no clobber on. So actually, I don't know if it's worth talking about no clobber. When we go into our bash RC, you can set it so that your shell by default will never override a file. It will never destroy a file. But Otherwise, Unix and Linux doesn't care. If there's a file there and you move it on the top of it, goodbye file. And if it's a directory, it will put it inside of the directory instead of blowing it away. But, there's move dash n and move dash I. That's cool. Yeah, just move dash, yeah, dash I and n on Linux. Okay. All right. So anyway, you saw my find command, right? Find. And by the way, I kept going up to the other commands. The way to do that is to push the up arrow for you. You don't know how to search yet, but we will learn that later. You got to learn VI first. In case an insensitive large is your RI, yeah. I thought tab was automatically case insensitive. I don't know, but I agree that would be awesome. Yeah. There's other things like fuzzy finder too. So um I think I don't use fuzzy finder. I don't know it. I don't know fuzzy finder. Fuzzy Finder is supposedly a thing that lets you partially type the name of something in a directory and it'll pull it up. A lot of people love it. Yeah, is it ls to Fuzzy Finder? This is not something that comes with Unix or Linux. This is something you have to install. But if you do this, then you can go pick, what files you can start typing your file, and then they'll do your thing. Um, I mean, it's worth looking at. I might look at it again. People use that a lot when they use their editor and they want to get to a file and they don't want to have to like look at the whole thing. I wonder if you did a find dot and then local. Sheesh, that's why I like it. That shows me everything with local in it right away, and I don't have to run the find command. There's everything with vim in it. Damn, I could be convinced to like this. I am still old school though, and so my way of doing that would be find dash name, local, and then it gives me the files. The reason I like find like that too is because you can actually write find into a script, and you can rename all the files with one command. Just make note of it. We're not going to go into all the amazing things you can do with the find command today, but you can do pretty amazing stuff. A lot of people use fuzzy finders inside of Vim, and then they don't have to exit Vim. And the people that do that are usually the people who are so loaded up with NeoVim plugins that exiting NeoVim takes 2 seconds. So they use NeoVim or Vim just like most Emacs users or VS Code users, and their startup time is abysmally bad because they have so many tree sitting plugins and all kinds of crap. So they don't ever want to leave their Vim. Yeah, my NeoVim takes 50 milliseconds. I mean, that's still pretty fast, but it's like so. Yeah, yeah, but fuzzy binder can be a problem with that. So, um, we're kind of getting off the rails here. It's kind of our because we're winding down here. Let's stay back with the beginner stuff. Renaming files and directories. I've talked to you about how to rename them. Uh, yeah, yeah. Well, then you're you're probably not tree sitting everything automatically then. At least not the way I am. I wish I weren't, but yeah. Um, so moving files under directories. We talked about that with MB. You can rename things. You can move them into other directories. You can move them up a directory. You want to move it up. So let's do that once. So say you're in docs and you want to move a rig name up, right? You can dot dot and it will move it up to, you don't have to slash if you don't want. That'll move it up to the current directory. Now it's not here anymore. You come up back up here, cd dot dot, and that takes you here. Okay, so I've been using the cd command a lot. It stands for change directory. It's one of the most common things you'll ever do. And so make sure you put that in your list. But here's the thing. CD, a lot of people don't know this, okay? CD dash will toggle you between your two things. It's the same with the GitHub command line tool, by the way. If you do git switch dash, it'll switch you between branches. So the use of a single dash by itself, you'll run into this all over. And what it does is it toggles the previous value. I actually have this built into my topic thing. If I do topic T, that will switch my my Twitch topic back to the one it previously was, and then I can go back and forth between the two. So you're going to see that a lot. Um, a lot of people will do this, and they'll type this unnecessary tilde, which is really hard to type. You got to do shift and then get it right and everything. Useless. And this, I guarantee you, there's at least one person watching this video that will not know this. If you do CD enter, it automatically CDs into your home directory or tilde. So typing the tilde is unnecessary. That's right. For 40 years, you've been typing CD space tilde, and the entire time you could have just been doing CD enter. I know a couple people just had their mind blown. If you know how hard tilde is to hit right, now you know you don't need to do that. People don't know this. In fact, 3 people in the chat just now did not know that. Someone just learned that after 7 years of using Linux. I learned about it on stream 4 years ago. 4 years ago, I learned about that on stream. For moving too fast, you learned it on accident. Yeah, so and we're gonna do CD dash to go back there. So yeah, it seems like a small thing. A beginner's watching this and they're going, well, what's so bad about typing tilde? The number of times you type CD to get into your home directory in your life, and you have to do that crazy pinky squish to get the tilde, you'll thank me later. Yeah, I promise you will. Most of us learned about it on accident. I think I probably did too. My pinky doesn't need to do any more yoga. Exactly. So, so that's kind of a fun thing to learn. There's a number of like other little things too. So, what was the other one? Well, when we get to aliases, there's a really fun one. I'll save that for later. Um, that I didn't know. I didn't know for 42 years. I learned it on stream. Uh, the CD home. I know. Can you imagine? Link one file directory to another. Okay, this is a little bit tricky, and I'm going to promise you right now, I'm going to get this wrong. I have never been able to do a symlink without looking it up. And I cannot tell you why. Okay, so first of all, I'm gonna do two types of links, okay? So it's always source target. Okay, so what are we doing? We're making a link to another file, okay? So I'm gonna do a symlink. So first of all, I'm gonna do is just a regular link, and everybody will do this because every beginner does this. It's the ln command. It creates a link. So we're gonna create another file, um, another file question mark to a rig name. No such file or directory. You know why? Because I did it wrong. Because I always get it wrong. So the first one is the source. And the second one is the new thing. All right, now I type ls touchdown. Okay, now I want you to see this. I never get this right. Uh, I prefer CD home. Who am I? All right, so what do we see that's different here? We have a rig name. Has anything changed here? Who can see it? What changed? We have another file and a rig name. It looks like I have two files there. I'm waiting. Somebody watching this is going to see the thing that's different. What is different between those two? The two after permissions. Okay. All right. So as we earlier talked about with an inode, this number here is the number of hard links to the file. So with a hard link, you get what appears to be two separate files that are pointing to the underlying, either the same inode or the same, uh, you know, associated data on disk. So yeah, so those two things. And if I add another one, so if I do a rig name, which is cool because you can actually use another file now because because these are hard links. You could say yet another ln-l, and you see the number goes up to 3. So, but just looking at this, off the cuff, you would not see these as separate files. In fact, if I do a user bin open, let's open this in the graphic finder. You will not see these as different files. There's no way to know. And the graphic user in the graphic system, you see one, two. You can see those files are all there, right? And what happens if I delete one? Now, the important thing here is these are all equally relevant. So I can actually delete the original one, move to trash. Actually, that it's still going to be around. Watch. Yeah, you see how come it's around? Because I didn't empty the trash. It's in my trash, and I have to fucking empty. Where the hell is my trash? I want to empty my trash. Now I don't even know where the file is. Where's my trash? I fucking. Did I swear again? I've been swearing a lot. I'm so sorry. I'm so sorry. It's because I'm using the graphic user interface. It makes me swear every time. Where's the trash? Okay, here it is. Trash, empty trash. Should I empty the trash? Sure. All right, now let's see what happened to our hard link. Yeah. Okay, so now we only have 2 hard links. So when I use the UI, the graphic user interface, all I really did is move the file. I just moved it into the trash, and there is a place on here where you can find it. I don't know where it is. Um, it's probably in your user's trash drawer or something. And so yeah, and you can make a script called trash if you want to control your own trash, if you like to keep files around and you're too afraid. Kind of a useless thing to have in the age of Git, which is where everything should be in a source repo anyway. Um, hidden directory data so dot trash. So is it dot trash in this current directory? I don't think it is. There's not there's a trash directory someplace else. I don't want to find it right now. Is it local share trash? On Linux, it's just local share trash. Ask friend if he knows the CD utility thing. All right, so um, anyway, you can see that by deleting the original file, it didn't touch this file. In fact, I'm gonna echo something you don't know about this command yet, but you'll learn this next week. Now, if I show you what's in the file and I cat yet another file, you'll see it's the same thing because it's pointing to the same underlying file. And and but the important thing is you saw that when I deleted the original, the other stuff was still around. And so the only way to get rid of it is to delete every one of them. You have to delete all of the replicas, right? And we can do that. So let's go ahead and RM another and yet another. We're not going to do wildcards yet. We'll cover that next week. And so now those files are gone. So let's go ahead and make another one, new file. Let's do a rig file. Rig file. So now we have another file, and we want to make a symbolic link to the file. Now, you're going to see immediately what the difference is. The difference is ln-s for symbolic. And then we're going to type the original file and then the new file. So the symlink file. And now we have something different, right? We have, first of all, an L here. So this is a different inode entry. It is a full inode entry. And it is a thing, is what I'm trying to say, on its own. And it's pointing to a rig file. And how do we know it's its own thing? Because if I move a rig file to new name, I will break the symlink. Wait, what happened? Yeah, it's not showing me a broken link. That's too bad. My Mac OS does not show me the broken link. I'm going to show you this on Kali. It's much more entertaining on Kali or any Linux. If I break a link like that over here, so let's say if I make a directory, it's like touch rig file, and then I ln-s rig file to symlink, and then I move the file. I need to touch grass. I do. Move original file. Wait, what? No, remove original file. And now you see, okay, this is normally what you would see. In fact, okay, so you see how it's red? That's because there's no original file. If I try to open it, let's say I were to try to, like, I don't know, VI the symlink file, it's like, no, can't do it. Doesn't exist. Command not, well, is there only BIM here? What? Is this GPAC? Oh my God. Never mind. Let's try cat. Let's just file. So the symlink says the file doesn't exist anymore, right? I mean, it's pretty obvious how that's different than the hard link. The hard link, both of the inodes were pointing to the same thing. In this case, no. In this case, the symbolic link is pointing to a file that doesn't exist. If I create another file that exists at that location, let's say it's in a Git repo and I pull it down fresh, it will still point to whatever that file is. It doesn't change it because it's not technically the same file. It's a separate file pointing to that file. So we can touch a rig file and that will resolve the thing and then the thing's all good. And I can tag a rig cat rig file and it'll work. Right? There's nothing in it, but you get the point. So, um, yeah. And so that's the difference between a symbolic link. Now, the other thing to note here is that the symbolic links are relative. So, like if I go into a different directory, um, you can move this symbolic link and it won't point to the same file. It points it to it relative to its current location. So what I'm saying by that is like if I let's do this. If I make a directory like foo and I make I move a rig file into slash foo and then ls-l symlink will break obviously because it's not pointing there anymore. But if I make a new link, if I say I want the symlink here um to point to foo a rig file. Oops, I did it wrong. I always do it wrong. Symlink. All right, okay. That's because the symlink already exists. There's another thing, F, that'll change the symlink. And so, yeah, so ls-l. So that symlink, whoops, and that symlink is now pointing to a rig file, right? If I move a rig file, it will break. But not only that, if I move the symlink file, it will also break. So if I make a new directory called bar, and I move symlink into bar, um, you'll see that it loses its reference to symbolic link because the reference is relative. Okay, the reference is relative. Now, there's a way to get around this, and I'm going to show you right now, just because we're on the topic, but you'll understand it more later. And that is to use something called the PWD environment variable. So the way to get around that is to make a symbolic link that points to the fully qualified name. Put that in your notes. The fully qualified name is everything from the slash at the very beginning all the way up to the file. So if we go back here, let's move symlink back out where it's working, right? We're going to move it back out and we'll come back out and we'll take a look now at everything. And you can see that the symlink is pointing, it's all working and everything because it's relative. You see this? Foo/original file. Now, it just so happens that the reason you know this is relative is because it doesn't have a slash in front of it, right? And it's kind of hard to see what we're about to do because we're only one directory deep. So let's actually make it more interesting, right? So if I make a directory under foo, uh, actually, no. Let's make a directory under bar called foo. Let's move foo and a rig file into bar. All right. Now our symlink is broken because why? Because it's pointing at, that relative location. Now watch, I can fix it because it's relative. The point of this is that symbolic links are by default relative. So this is great if you're saving a ticket. I actually have this problem at work. because they have been using relative links, and when you rsync, you can break things if they have to move around. So we're gonna move symlink into bar. So now everything is in bar together, and let's see if it works. Okay, it doesn't quite work because where did our foo go? Did I put foo under here? Where's foo? Oh, I didn't move foo yet, apparently. I thought I did. Okay, so we'll go into bar. All right, so bar has, oh, we moved original file, okay. And so now we have foo in there, and the symlink is still broken because it's pointing to a rig file. Oh, I moved a rig file. All right, let's move a rig file back into foo. And now the symlink is working because relative path. Relative path means from here on. Now I can make relative paths that go up. They can be dot dot whatever, and that means it's referring to this file in the parent directory. And I can do dot dot slash dot dot and go all the way up. Or I can use a fully qualified link. And if I were to do that, then that always points to that one at that spot. And as long as it's not moving around, it'll be fine. So what do I mean by that? So I could actually make this symbolic link. We can actually remake this symbolic link. And let's do that. ls-sf to redo it. We're going to make it point to foo. Instead of to foo, though, foo a rig file, which is what it would do now. We're going to do a little trick. And we're going to do something. I want you to try this. We don't know echo yet, but pwd. Oops. This pwd is the text of the current working directory. So this is the first time you're going to see that what we're using the command line, we're actually coding. Every single line that we write is a line of code. And we're going to come back to that a lot later. So ln-sf is now, we can type pash pwd, and just in case there are spaces in there, we don't know, there might be spaces in there, let's put it around quotes. And now we can say slash foo slash rig file, and we get something totally different. So did I call it a rig file? Bad me. Let's call it, oh, you know why? Because by default it links to the same name, and I forgot to put the actual name. So let's make two links then, I guess. So now both of the things are pointing to this fully qualified name. Now, why is that significant? Because I'm going to remove a rig file. Now, remember before when I moved the symlink, it broke? When I moved the symlink before, it broke, right? Because it was relative. If I move the symlink, now I can move it anywhere. Let's move it under temp. There's no temp. Oh, whoops. Symlink under slash temp. Slash temp, which is a temporary location for stuff that it goes away when you reboot. So my symlink is still working. Why? Because it's using a fully qualified path. And a fully qualified path, or the full path, means it begins with slash. That's all. And that becomes super important when you start to deal with security or look for vulnerabilities or hack somebody, because a lot of times they won't use a fully qualified path and they'll use a relative path. And there are lots of ways to take advantage of that. So that's been way more than you ever wanted to know about how to link. The reason to do linking like this, so one of the common reasons, there's lots of reasons, but one of the most common beginner reasons is you want to put all of your stuff into a dot files directory. Um, this suggestion meets with a lot of controversy depending on who you ask. I still like it as my favorite way to set things up. I create symbolic links using the PWD to files, and then I put them where they must be in order to be observed in my home directory. So then when you ls any of those files, ls-l tilde dot, I don't know, was term, .lua, you see that is a fully qualified symbolic link pointing to a fully qualified symbolic link. And why is that valuable? Because when I make changes to my git.repo, like I want my configuration files and stuff, and I do a git pull, and I pull down all of my stuff, it just works because the files, according to my system and all of the applications on my system, The files are where they need to be, even though they're not actually there. And that's a hugely controversial point. A lot of people think that that's a bad idea. A lot of people think it's a good idea. I think more people think it's a good idea than bad. But what that does is it allows you to point things to maintain those files in a repo under source management, which we kind of talked about last week, and then link to them. So you end up with, setup scripts that create all of these links for you up front, but it saves you a lot of time in the long run. Because the alternative would be to this would be to copy that file to that location, and then when you pull down your files from Git, if you ran setup again, you'd have to also put them there, right? And I very frequently will change something in one of those files at its location in my home directory. And it doesn't matter because I'm also changing it in my Git directory so long as I add it later. So you'll see in the plan for Obsidian in our docs, we're going to be creating our own doc files in GitHub repo, and we'll be coming back to the symbolic link thing a lot for that purpose. I believe that concludes today's conversation about file systems, about understanding them. Uh, a thing I would suggest that you seek to understand is what are the different locations of the file system. As a beginner, you don't really need to know all of this. We talked about one, which on Unix is /proc. We talked about your home directory. Yeah, I did it that way. Your home directory, which is where all your files live, your main files. We talked about /temp, and that's where you can put temporary files that you're going to just throw away. To tell you the truth, you really don't need to know anything other than that as a beginner, right? Yeah, if you go into, so let's say you're a beginner that's going to go into coding, you're not going to need to know about /dev or /proc or any of those even the mount point stuff that we talked to you about. If you become an administrator or a DevOps person, you probably want to know all of that. But if you just want to know how to survive and write code, you need to know your home directory. You need to know whether you're in the home directory or you're in root, and then you need to know about temp because you're going to put stuff in temp all the time while you're writing code that you want to modify a temporary file and then bring it back. So those are really the only locations that you need to understand. Um, and applications have special things that they demand and require, and that's why LAL, you'll see them here. And each one of those applications is different in its expectation. When we start writing code, we will talk about some of that. Um, like for example, .local and dot, got dot .ssh and dot .config and dot .state. There are some standard files under your home directory that you should be aware of, especially when you start coding. But we're not going to get into those until we start coding. But in general, in your home directory, there's going to be a lot of hidden files that are there to help configure your different applications, and you're going to need to know how to create those files and put those files there. So that's it. If you have a dot plan, I have a dot plan. Yeah, you can finger my plan if you want. We're geeking out our old fart style. It used to be in old multi-user Linux, there's lots and lots of fun things. In fact, if you're on a multi-user system, you can have a lot of fun with commands that are completely irrelevant today, but are designed for. There used to be a command called finger, for example. Yeah. You could, and I kid you not, this is the exact vernacular. You could finger your friend to figure out what they were doing, and it would show you their dot plan and their dot project file to see what you were working on. This is way before the internet even happened. The closest thing to social media back then was a multi-user Unix system, and you could finger somebody and you could chat with them on the same system as long as you were all on the same system. These are things that, again, they predate the internet by at least 10 years. You could definitely finger somebody. You could finger them, you could poke them, yeah, you could talk them. I'm not gonna lie, I kind of wish those days were back again. because it was fun because you had the sense they were all working on the same machine. It was this like real sense of locale. You could type users or you could type who, and it would show you all the people that were on the system. And you can't do any of that now. I'm strong. If you want to play with that kind of stuff, go on Pico CTF and get on their multi-user system over there, and then just like have fun. You can see all of the users that are all logged in simultaneously and stuff. I used to make. For the record, I used to have a shared server for all the students that I had. It was like some 500 people, and we were all on the system together. And I would encourage them to hack each other because if they, that permission stuff that we just did, if you do your permissions wrong, someone else can read your files. But not only that, they can actually modify them. They can put stuff in your directory and say, "I was here." It's kind of fun, and it teaches you a lot about permissions. But to tell you the truth, all of that stuff is really irrelevant in the containerized world. It's really not relevant today. You do still need to know it because there are ways you can expose yourself. Yeah, I said that. But one of the reasons that I don't do a shared server is because the main reason is because everybody has to access through the internet, and if they don't do it properly, um, the system can easily be denial of service attacked or infiltrated by external hackers, and then they can just own the whole time and the whole system. Because, and I know Dennis does this. He doesn't mind everybody being in there because he's in a system that's secure. It's a kind of honeypotted away. But I don't. It takes a lot of work to manage that kind of system. So we don't do that anyway. And it's not relevant to you getting a job. It's important you know the general idea, though. God, my teeth hurt. I got to find my teeth pulled out 2 days ago. My front teeth just got pulled out. My roots just got pulled out. Yeah, my roots got pulled out 2 days ago, and I got stitches in my face. And I've been talking for 3 hours. So, time for me to go. I'm going to take off. Love you guys. Um, let's go ahead and end this video, and then I will rate out. So, I'm going to go pick up the antibiotics on my fixie right now. Yeah. So if you want to hang with me for that, we'll talk about that in a bit. Bye, YouTube.